Right. Yeah, good evening, dear students. Yeah, good evening to everybody. I hope all of you have joined to the class. Yesterday, we have discussed about the short pitch winding, and we are completed the short pitch winding in total. Short pitch winding, if the coil span is equal to 180 degrees, then it is said to be full pitched winding. If coil span is less than 180, it is said to be short pitched winding. But with short pitch winding, the effect of harmonics can be eliminated. And we have seen with short pitch winding, the Kp value, Kp7, Kp5, if you take, the Kp values are going to be reduced. When Kp reduced means the corresponding generated EMF also reduced. Correct? Yes. Yeah. By using short pitch winding, any nth harmonic can be eliminated. But to eliminate any nth harmonic, it's alpha. Alpha is equal to 180 by n. And beta, coil span, beta is equal to 180 into n minus 1 by n. Okay? Yes. But generally, in alternators, not only alternators, almost in all AC machines, the coil span will be kept up 150 degrees. Or they're short pitched with an angle of 30 degrees. 30 degrees alpha is very common. It's not only alternator, all AC machines, induction motor, generator, if you take all machines, 30 degrees, most of the cases. And I told the coil span is 120 to 150. 150 is the best choice, of course, because with 150, maximum percentage of 5th, 7th will be eliminated. Okay? Yeah. And advantages of short pitch winding we have gone through. The advantages, mainly elimination of harmonics. With the elimination of harmonics, the corresponding losses also can be eliminated. Saving of copper at end connection. When full pitch winding, more copper is required at end connection. Its length is more. Short pitch winding, less length. Whereas over pitch winding, more length. That's the reason practically winding is never be over pitch. Okay. Yeah. Now, then in this class, let us start the next topic is another important topic, that is distributed winding. Distributed winding. Distributed winding. Distributed winding. Distributed winding. The armature winding, it can be distributed or it is concentrated. But what is the difference between distributed winding, concentrated winding, and what are the advantages of the distributed winding? Okay, that we are going to see. Okay. To discuss the distributed winding also, let me take a simple example. With that example, we will draw the distributed winding and we will come to all the conclusions. We are going to define the distribution factor, right? So for easy understanding purpose, let me take minimum number of slots, minimum number of poles. Consider a three-phase 2-pole 18 slot alternator. 18 slot alternator. 3-phase 2-pole 18 slot alternator. And for this, slots per pole, S by P. How much? 18 by 2. Slots per pole is 9. Slots per pole is 9. And slots per pole per phase. Slots per pole per phase. That is, let me call SPP M. Slots per pole per phase M. M is equal to 18 slots per pole to per phase 3. Slots per pole per phase. That is equal to how much? It is equal to 3. Slots per pole per phase is 3. M. Slots per pole per phase. And the slot angle, gamma. Slot angle gamma is equal to P into 180 divided by S. P into 180 divided by S. P is equal to 2 into 180 by 18. How much? It is 20 degrees. Gamma is equal to 20 degrees. Okay. Yeah. So all these points must be this data. I am going to change the next page. Na? It is clear. A 3-phase 2-pole 18 slot alternator. Slots per pole is 9. Slots per pole per phase is 3. That is SPP. I am going to use the right symbol M. Slots per pole per phase 3. Slot angle gamma 20 degrees. So for this, let me draw the distributed winding. So 18 slots. Slot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 slots. 18 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18 slots total. 18 slots. Under that, 9 slots for North Pole, 9 slots for South Pole. 9 slots for each phase. 9 slots for each phase. See, these are the 9 slots for North Pole. Nine slots for North Pole and 9 slots for South Pole. 9 slots for South Pole. Okay? And what is the number of slots per pole per phase? 3. Kada. Out again? Yes. You ready? You need to follow. So let us, if you are writing, you make it a bit fast and simultaneously you have to concentrate on the discussion. Okay. Among these 9 slots are there, 9 slots are there under North Pole, 9 under the South Pole, 9 under the South Pole. Then slots per pole per phase is 3. Means under North Pole, first 1, 2, 3 slots belongs to R phase, 1, 2, 3 belongs to R phase, and 4, 5, 6 belongs to another phase, 7, 8, 9 belongs to another phase. Like under South Pole also, even under South Pole also, this is South Pole. Under South Pole also, 3 slots for each phase, 3 slots for B phase, 3 slots for Y phase. That is the slots per pole per phase. First, let me draw the R phase winding. R phase winding is kept in the first slot. Beginning of the R phase winding is kept in the first slot. For full pitch winding, ending can be kept in the 10th slot. Correct? Because what is gamma? Gamma is equal to 20, na? Here you see gamma is equal to 20, slot angle 20. When slot angle 20 means for full pitch winding, if you take 1 to 10, slots per pole is 9, na? When slots per pole is 9 means for full pitch winding, what is the coil span? 1 to 10. So that is said to be 9 slots total. 9 into 2 is equal to 9 into 20, 180. Or else, let me count here. Once you are keeping beginning of the first coil under first slot, for full pitch winding where it can be kept, count the angle from here. slot 1 to slot 2, 20 degrees, gamma 20. 20 plus 20, 40, 60, 80, 100, 120, 140, 160, 180. 1 to 10 is nothing but it is said to be 180 degrees. 1 to 10, it is said to be 180 degrees. 1 to 10 means 9 slots, net 9 slots. 9 slots means 9 into 20, 180. Okay? Yeah. For full pitch winding. If you want short pitch winding, what to do? You can keep, instead of keeping the 10th slot, we can keep in the 9th slot. 9th slot or less than that. But here, if I keep R phase winding in the 9th slot, dear students, if I keep full pitch winding at one side here, other side is the 10th slot. For full pitch winding, for short pitch winding, instead of keeping the 10th slot, we need to keep in the 9th slot. But 9th slot, you need to keep B phase or Y phase. Okay. Because 3 slots for R phase, 3 for Y phase, 3 for B phase. Say the 7, 8, 9 belongs to B phase. 9th slot, you need to keep B phase. But for short pitch winding, full pitch winding, R phase is in the 10th slot, and short pitch winding, other side of the coil, you need to keep in the 9th slot. But 9th slot already B phase is there. How can you keep? How can you keep? That can be kept in double layer winding. Are you getting my point? This is, see, I need to keep here B phase, okay, or Y phase, say. And in the same slot for short pitch winding, you need to keep R phase. How can you keep? It is possible with double layer winding. Double layer. R dash I can keep. And the top layer is one phase and bottom layer I can keep the R phase. Okay? Short pitch winding is possible only with double layer winding. That's the reason alternates are generally they will be double layer winding. Why? Because with double layer winding only short pitch winding is possible. Short pitch winding is possible means if you want to keep in the 9th slot, compulsory 9th slot, B phase or Y phase has to be kept. Then in the same slot, you need to keep under the bottom layer. Okay. So double layer winding, short pitch winding is possible only with the double layer winding. Anyhow, that I am going to draw. But first, I would like to mainly highlight that what is a distributed winding. Distributed winding, let me take single layer winding. So with the single layer winding only, full pitch winding is only possible. Single layer, full pitch winding only possible. So I will take distributed winding and full pitch. Under distributed, full pitch I will take. Short pitch, how it is going to be? That is possible with double layer winding. But mainly, let us focus on distributed winding. And already we know what is the short pitch winding now? Yes. Okay. Yeah. So R phase winding. R phase winding, I am keeping here. R phase winding is kept in the first slot. For full pitch winding, other side must be kept in the 10th slot. In the 10th slot. 10th slot. And the second coil of the R phase, can be kept in this slot, second slot, and other side of the coil can be kept in the 11th slot. Similarly, third coil is kept in the 3rd slot, ending can be kept in the 12th slot. So this is the R phase winding. We are keeping this is R, say R dash, R and R dash. So for R phase winding, we are keeping in the 3 slots. 3 coils are there, na? So for example, if you take this is R1, R2, R3, R1, R2, R3. This is R1 dash, R2 dash, R3 dash. So R phase winding, 3 coils are distributed in the 3 slots. They are distributed under the 3 slots. Correct? They are keeping in the R phase winding in the first slot, second slot, and also 3rd slot. We are distributing 3 slots. Similarly, other side also 3 slots. Next, where Y phase winding, must be kept in the 120 degrees apart. Okay. Yeah. So this R phase is clear, na? Yes. R phase winding, 3 coils are there, but 3 coils we are connecting in series. First coil ending R1 dash is connected to R2 beginning, and ending of second coil is connected to beginning of third coil, and end of the third coil is right R dash. So 3 coils are connected in series, but they are distributed in 3 slots. Okay. Alternator winding is lap winding. Lap winding. Lap అంటే one after the other. No question of wave winding. Lap. Okay. Similarly, Y-phase winding. Y-phase winding has to be kept at 120 degrees apart. R1 to Y1 must be 120 degrees. Correct? See, this is your stator core. Stator core. R phase winding is kept here. Y phase winding must be kept here. B phase winding must be kept here. So the R to Y and Y to B must be 120 degrees apart. For example, this is R1, say R1 to Y1 120, Y1 to B1 120. Similarly, R2 to Y2 also 120 degrees. We want balanced winding, balanced winding. So therefore, R1 to Y1, Y1 to B1. Compulsory it must be 120 degrees. Then only you will get generated EMF is 3-phase waveform, balanced EMF. I have given very beginning classes. When winding is spatially displaced 120, then only you will get generated EMF is phasally 120 degrees. Therefore, R1 to Y1 120, Y1 to B1 also must be 120 degrees. Beginning of R phase to beginning. Then automatically second coil to second coil, it will take 120 degrees. Therefore, so Y phase winding can be kept 120 degrees apart. So let us come back to our diagram. This diagram, yeah, where Y phase winding must be kept in the 120 degrees apart. 120 means where? Tell me. This is R1, R1. R1 to R2. This is 20 degrees. Gamma 20. 20 plus 20. 40, 60, 80, 100, 120. 1 to 7 is 120. 1 to 7 means how many slots? 6 slots. 6 into 20 degrees is equal to each slot 20 degrees, na? Yes. So that is equal to 120. Right? You want 6 slots. 6 slots means 1 to 7. So Y phase winding must be kept in the 7th slot. 7th slot. Y1, Y2, Y3. Y1, Y2, Y3. They can be kept in the 7, 8, 9. But where ending must be 180. Full pitch winding I am writing. Full pitch winding. Where Y1 dash, see, count the angle from 7 to. 7 to 180 and 7 plus 9. 9 slots it is required. 7 plus 9. Where you will get 60. 7 to 7th slot. 20, 40, 60, 80, 100, 120, 140, 160, 180. 16th slot. 7 plus 9. Full pitch winding, na? 180 degrees you want. So I can keep Y1 dash, Y2 dash, Y3 dash. Y1 dash, Y2 dash, Y3 dash. They are kept in the 16, 17, 18. So Y phase winding, we can draw the Y phase winding can be kept like this. Is a Y1, Y phase. Ending is Y1 dash, one coil, other side of the coil, the 8th slot, 17th slot. Again, these 3 coils we are connecting in series. This is Y and Y dash. Okay. This is Y and Y dash. Y phase here, Y dash here, Y dash here. That is for Y phase winding. Y phase. Y phase. Now B phase. B phase. Y1 to B1 also 120, na? Yes. Y1 to B1 also 120. R1 to Y1 120. Y1 to B1 also 120. Right? So Y phase is completed. Y phase 3 coils, all they are connected in series. Now B phase. The B phase can be kept. 7 plus 6, na? 7 plus 6. You want 120 degrees means how much? We are at 7th. Y1 is at 7th. But 7 plus 6, that is equal to how much? 13th slot. 7 plus 6, 13th. 7 to 13 means 6 slots. 6 slots. Therefore, 120 means I can keep in the 13th slot. 13th slot. 13th slot, B1, B2 and B3. B1, B2, B3 can be kept in the 13, 14 slot. And where other side? Other side can be kept in the 14, 15th slot. Okay? Because this is closed one, na? This is a closed one. First and 18th slots are adjacent slots, the closed one. So therefore, if I am keeping the 13th slot, say, and it can be ending can be kept in the 4th slot, 4th, 5th, 6th, 4th, 5th, 6th. So therefore, B phase winding. See, this is B phase beginning and ending can be kept like this. Ending can be kept. This is B. Other side, yeah, this is the B phase winding. B dash. This is B dash. So B and B dash. Okay. B1 dash, B1 dash, B2 dash, B3 dash. So this is the total distributed winding. Distributed winding. Fine. Okay. For star connection, what we will do? For star connection, R phase, Y phase, B phase. We are getting this R phase, na? Yes. Finally, if you want B phase, B dash, R dash, Y dash, they are connected together to form the neutral. To form the neutral. This is the neutral point. Neutral. N. Neutral. R dash, Y dash, B dash connected together. And finally, which phases we can take? R phase. We can take this is R phase. Okay, R phase. And Y phase. The Y phase. Y phase. B phase. The B phase. B phase. Y phase. So this is a star connection. Generally, we will connect our alternatives in star connection. Fine. So don't worry about this diagram. No one will ask to draw the diagram. It is clear. Distributed winding. The armature winding is distributed in all the slots. Okay. Now coming to the important terminology. Ultimately, we have to, what type of questions that can be asked in the gate examination is important, na? Yes. See, the important terminology here is R phase winding is distributed among 3 slots, no? R1, R2, R3. R1, R2, R3. This R1, R2, R3 is called a phase belt. This is said to be phase belt. R1, R2, R3 is called a phase belt. R phase belt. This is said to be phase belt. This is phase belt. Phase belt. Or let me write in the next page. I'm not going to draw the entire diagram, but having some idea. See, R phase winding we are distributed, na? Yes, R phase winding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6, 7, 8, 9. R phase winding we are keeping here. Where R1 is R1, R2, R3 we are keeping. Okay, R1, R2, R3. These 3 slots are said to be one phase belt. We will call this is 1 and 2 and 3. This is called what? phase belt. This is said to be phase belt. Phase belt, or it is called phase band. Phase band or phase groove. Phase groove. Like similarly, Y phase also it will have its own phase group. R phase belt, it is said to be R phase belt. So therefore, phase belt is nothing but phase belt. Phase belt is the group of slots belongs to each phase. Is the group of slots belongs to each phase. Belongs to each phase under each pole. Each phase under each pole. That is a phase belt. So phase belt is the group of slots belongs to each phase under each pole. This is a phase belt. So therefore, how can you write phase belt? Phase belt can be written as phase belt is equal to how many slots? In this example, so number of slots per pole per phase. For phase belt, it is 3 slots, I can say 3 slots. 3 slots in this example. Phase belt is the group of slots. No, group of slots belongs to each phase under each pole. You're getting? This is our original diagram. Na? Look at this diagram. Look at this diagram. How many under north pole, dear students, concentrate. Under north pole, how many slots are there? 9 slots are there. 9 slots means for each phase, how many slots are there? 3 slots for R phase. These 3 slots are said to be R1, R2, R3. 1, 2, 3. These 3 slots are said to be one phase belt. That is R phase belt. Similarly, this is said to be B phase belt. B phase belt. And 7, 8, 9 slots together is said to be Y phase belt. Y phase belt. So phase belt is nothing but group of slots. This group of slots belongs to each phase under each pole. And under north pole for R phase, how many slots? 3 slots are there. That is said to be R phase belt. R phase belt. Similarly, this B1 dash, B2 dash, B3 dash is said to be B phase. 7, 8, 9 Y phase. So therefore, phase belt is equal to 3 slots here. 3 slots. 3 slots. In this example, it is 3. But general case, how much? M slots. M. See here, this is M, na? Slots per pole per phase. That is itself phase belt. The meaning is number of slots for each phase under each pole. How many? 3 is there. But general case, it is a SPP. M slots. M slots. So therefore, I can write here. It is said to be phase belt is M slots. M slots. Phase belt is the M slots. Okay. Yeah. Next term is phase spread. Next term is phase spread. Phase spread is the angle subtended by each phase. Phase spread is the angle subtended by phase belt. Angle subtended by phase belt. Phase spread is the angle subtended by phase belt. Therefore, what is the phase spread? Phase spread. These are the 3 slots. Na? 3 slots belongs to R phase. I am taking about only R phase. Similarly, you can assume other phase. The earlier page I have drawn. Na? Yes. See, these 3 slots are there. Na? How much angle they are spreading? Actually, it is circular shape. Na? Circular shape. It will be circular shape. Okay. So, in circular shape, 3 slots, how much angle it is spreading? 3 slots, each slot 20 degrees. 20 degrees. Therefore, how much angle? 3 into 20. Phase belt is nothing but number of slots for each phase under each pole. But phase spread is nothing but how much angle it is spread by phase belt. So therefore, what is the phase spread? Phase spread is equal to 3 slots are there. 3 slots. Angle, phase spread is nothing but angle. 3 into 20 is equal to 60. But general case, how much? General case, it is 3 is nothing but m and gamma, m gamma. Therefore, phase spread is equal to m gamma. Phase spread is equal to m gamma. And phase spread is depends on the number of phases. Phase spread is depends on number of phases. Number of phases. Number of phases. Phase spread for n phase machine, is equal to 180 by n. Phase spread for n phase machine is equal to 180 by n. 180 by n. The phase spread for single phase machine is equal to 180 by 1. How much? 180 degrees. Phase spread for single phase machine, it is 180 degrees. Phase spread for two phase machine is equal to 180 divided by 2. How much it is? 90 degrees. 90 degrees. Similarly, phase spread for three phase machine is equal to 180 by 3 is equal to how much? 60 degrees. 60 degrees. So phase spread for n phase, where n is the number of phases, it is 180 by n. 180 by n. Okay? Yeah. 180 by n. Single phase. There are three types of alternators that are existing. What are the alternators? Single phase alternates are there, two phase alternates are there, three phase alternates are there. So for single phase it is 180, two phase 90 degrees, and three phase it is 60 degrees phase spread. Phase spread is 60 degrees. First of all, can you tell me what is this 180? How this relation is existing? 180 by n. What is this 180? 180 is the phase pole pitch. 180 is nothing but pole pitch. Under north pole, how much angle total? North pole total angle is equal to 180 degrees. 180. Okay. For three phase machine, if you take that 180 degrees, under north pole, you need to keep all the phases. All the phases, no? Yes. So for example, see here in our diagram, R phase winding. This R phase winding. Under north pole, total 180 degrees. Pole pitch is equal to 180. 180 degrees equally shared. R phase winding 3 slots, B phase winding 3 slots, Y phase winding also 3 slots. But 3 slots means what is this angle? 60 degrees. 60 degrees for R phase, 60 for B phase, 60 for Y phase. Compulsory we need to keep under north pole all the phases you have to accommodate. That's the reason 60, 60, 60. 180 by 3, 60. If two phases say, two phase means that slots will be equally divided for phase 1 and phase 2. So 180 degrees is equally divided, 90, 90. If it is a single phase, say, single phase means total pole is related to only one phase. All coils are kept at beginning under north pole, endings are kept under the south pole. Okay. For your kind information, for the same data, for the same given example, can you draw the single phase winding? Single phase winding, how it would be? I have drawn for three phase star connection. Okay. Can you draw for single phase? It is very easy. Dear students, listen. For single phase, how it will be? First coil is in first slot now, and next one is 10th slot. See, first coil, 10th slot, and second coil, 2. 1 1 dash say. 1 dash is 10th slot. 1 1 dash, 1 1 dash, 2 2 dash, 3 3 dash, 4 4 dash, 5 5 dash, 6 6 dash, 7 7 dash, 8 8 dash, 9 9 dash. All coils are connected in series. Finally, you will get one beginning, one ending. But all beginnings are kept under the north pole. All endings are kept under the south pole. That is nothing but single phase. So therefore, 9 beginnings means the total pole belongs to only one phase. That is only single phase. Nothing is a single phase, and all coils are connected in series. That's all. Beginnings are kept north pole, endings are kept under south pole. You will get one beginning, one ending. That's all. Okay. Yeah. So for single phase, 180 by 1. 180 degrees is only belongs to one phase. Like for example, I may ask for 6 phase, say in future we may expect 6 phase, for example, theoretically 6 phase means 180 by 6, 30 degrees for each phase. Okay, fine. These are the, remember that these things are very important. Single phase 180. In the problems, you won't give 60 degrees, 90 degrees. You have to take it. Phase spread for 2 phase and you have to take 90. Okay. Yeah. Next. Then coming to the, let us see. Yeah, I hope this is clear, na? Phase belt. Yeah. The phase belt. Phase belt to phase group, or only one pole. Let me take 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. So under north pole, for example, under north pole, this we have taken, yes, where you have kept R phase. This is R phase winding. R phase winding we have kept R1, R2, R3. R1, R2, R3. So this is said to be, and similarly, we have kept, this is B1 dash, B2 dash, B3 dash. Whereas this is Y1, Y2, Y3, Y3. So these 3 slots are said to be, one phase belt. This is said to be phase belt, or phase band. And angle of this is nothing but phase spread. Angle of this is phase spread. Okay. This is said to be R phase belt. Right? Yeah. This is R phase belt. This is said to be R phase belt. This is B phase belt. And this is Y phase belt. Y phase belt. Y phase belt. And this is similarly B phase belt. B phase belt. Okay. Phase belt is equal to 3 slots. Now, then coming to the distributed winding. This is distributed winding. Now let us draw for concentrated winding. Concentrated winding. For same data, let us draw the concentrated winding. Because concentrated and distributed is a pair of winding. Correct? Concentrated and distributed is a pair of winding. Right? Why? Because you see, when you are drawing the winding, armature winding, how I have drawn? Armature winding. See, armature winding, it can be divided. Armature winding can be divided into concentrated and distributed. Concentrated and distributed. Distributed winding. Under that it is full pitch and short pitch. Full pitch and short pitch. Full pitch and short pitch. Full pitch and short pitch is said to be one pair. One pair. This is said to be one pair. Therefore, it is related to Kp. Related to Kp. Kp will be defined by winding, either you can have full pitched or short pitched. Right? But ratio of short pitch to full pitch, it is related to pitch factor. But whereas concentrated and distributed, this is related to Kd. Therefore, Kd is nothing but the induced EMF for distributed winding to induced EMF for concentrated winding. Generally, you can have distributed or concentrated. Of course, distributed is very general, concentrated is not used. But if you use concentrated when compared to the distributed, concentrated, what is the ratio of EMF? That we are going to define the distributed distribution factor. So therefore, what I am trying to say is, for the same data, for same machine, once it is distributed, what is the generated EMF? If same alternator, if it is concentrated, so what is the generated EMF? So comparison will be always distributed must be compared with concentrated. Full pitch must be compared with short pitch. Fine. So therefore, for same data, I would like to draw the distributed winding, concentrated winding. So let us take concentrated winding. Now concentrated winding. Okay. Concentrated winding, for the same data I am taking, same data, a 3-phase, 2-pole, 18-slot alternator only, 18-slot alternator, same data. Alternator. For that, what is the slots per pole per phase? Slots per pole is 9 only. Slots per pole is 9. Slots per pole per phase. Slots per pole per phase. SPP M. M is equal to, that will be 3. 18 divided by slots per pole per phase. It is 3. Gamma is equal to P into 180 by S. 2 into 180 divided by 18. 20 degrees. Same data I am taking. Same data. So for 18 slots, let us draw concentrated winding. For 18 slots, see, this is slot 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Nine slots for North Pole. 9 slots for North Pole, 9 for South Pole. Same example. Yeah. Okay. For same thing, R phase winding. If I draw R phase winding is kept under the first slot. First slot is R1. For full pitch winding, R dash can be kept in the R1 dash can be kept in the 10th slot. Can be kept in the 10th slot. 10th slot. 10th slot. And second coil of R phase also kept under the first slot only. First slot only. First slot only. First slot only. Ending can be kept. Third coil, second coil ending is kept under the 10th slot only. 10th slot. And third coil beginning also kept under the first slot. Ending is kept in the 10th slot. This is nothing but R dash. This is R and R dash. Is said to be concentrated winding. Concentrated winding. R phase coils are kept only in one slot. All endings are kept under the other slots. Right? This is R1, R2, R3. All they are kept under the same slot. Similarly, R1 dash, R2 dash, R3 dash kept under the same slot. All that together they are kept under the same slot. They are contained in series only. R1, R1 dash, R2, R2 dash, R3, R3 dash. But all the coils are kept under the same slot. That is a concentrated winding. Earlier, what we have done, R phase winding is distributed in the 3 slots. Na? We have kept R1 in the first slot, R2 second slot, R3 third slot. Distributed. Of course, they are connected in series. Distributed R1, R2, R3. But now all coils of R phase together, they bunched only in one slot. All together are kept only in one slot. Similarly, Y phase. Where Y phase, it must be 120 degrees apart. It is compulsory. 120 degrees compulsory phase difference. where we can keep in the seventh slot, Y phase beginning, and other side must be kept in the 16th slot. Second coil is kept here. All coils are kept in this slot. Okay, this is Y and Y dash. Y dash. The R phase windings are kept, Y phase windings are kept only one slot. This is Y1, Y2, Y3. All they have kept in the same slot. Y1, Y2, Y3. And these are Y1 dash, Y2 dash, Y3 dash. All they are kept only in one slot. Similarly, B phase also. B phase, all the windings, beginnings can be kept in the 13th slot now, 13th slot. B phase winding will be started from 13th. All they have kept in the same slot. Okay. Endings. All endings can be kept in the fourth slot. Yeah. This is B dash, and this is B. This is a concentrator winding. Even you can also connect all B dash, Y dash connected together. This is B dash is there na, B dash, R dash, Y dash. That will form the neutral. And finally, we will bring R phase. This is R phase. And this is Y phase, B phase. Y phase and B phase. Okay? Yeah. The concentrator winding. Now, I hope you have got what exact difference between concentrator and distributor winding. Okay, this B1, B2, B3. Nothing is there difference. Earlier R1, R2, R3 distributed among 3 slots, but here all the coils are kept on in one slot. Correct. I have observed earlier diagram, whatever I have drawn. See this diagram, earlier diagram. R1, R2, R3, they are distributed in the 3 slots. Correct. But all 3 together, R1, R2, R3 kept only in one slot. That is said to be concentrator winding. Okay. Similarly for all phases. Yeah. Can you tell me for this what is the phase belt? Phase belt is equal to only one slot. This is the phase belt. Phase belt, how many slots? Only one slot, na? Yes. Phase belt is nothing but the number of slots belongs to each phase under each pole. And some students will raise a doubt. Sir, we are keeping R phase winding. Listen carefully. Some students will raise a doubt. Sir, all R phase conductors are kept only in one slot, huh? Right? 2-3 slots are there, na? They are empty. Some slots we are utilizing under north pole. How many slots are required? Under north pole for 3 phase, only 3 slots are enough. R phase require 1 slot, Y phase required 1 slot, B phase required 1 slot. So under north pole, 3 slots are sufficient for each phase 1 slot. But remaining slots they are empty. That we are not going to utilize. Effectively, we utilize only 3 slots. 3 slots are sufficient for concentrator winding. 3 slots under north pole, 3 under the south pole. Whatever remaining existing slots, simply we are not going to use. If you are interested, only for concentrated winding, means I will create only 3 slots under north pole. 3 slots only I will create. I will design my machine for only 3 slots. If already existing slots say I am not going to lyse. I will use only 3 slots. Remaining slots are kept empty. Okay. Now, an important thing is, what is a phase belt? Phase belt is nothing but the number of slots for each phase under each pole. How many slots are there? Only one slot is there. Physically, they are existing. Physically, they are existing. We are effectively utilizing only one slot. So therefore, here phase belt is equal to phase belt. Phase belt is equal to m slots, no? M slots. But m is equal to how much? One slot. Space. Okay. I will go for next page. Now see, phase belt. Phase belt. Phase belt is equal to m slots actually. M slots is equal to one slot only. Effectively, we are utilizing one slot. Effectively, we are utilizing only. Physically, m is 3, but effectively one slot. And what is phase belt? Phase belt is equal to m into gamma. But m is equal to 1, m is equal to 1 into gamma. So that is equal to only slot angle gamma. Phase belt is equal to gamma. Phase belt is equal to gamma. No, phase spread. Phase spread is equal to m gamma. Phase spread. M gamma. Only one slot angle. Only gamma it is because m is equal to 1. All R1, R2 are kept in only one slot, 20 degrees only. In this example, it is phase belt. Phase spread is only 20 degrees. R phase winding is kept only in one slot. Y phase are only 7th slot. B phase are only 4th slot. Okay. Now, easy identification. What exact difference between distributed and concentrated winding? Distributed and concentrated winding, I can say, if m is equal to 1, it is said to be concentrated winding. So what is the m value here? M is only 1, m is 1. If, remember, if slots per pole per phase, that is SPP, m is equal to 1, that is said to be concentrated winding. Concentrated winding. If m is equal to 1, concentrated. If m is greater than or equal to 2, then it is said to be distributed winding. Distributed winding. If m is equal to 1, concentrated. M is greater than or equal to 2, distributed. Okay. Slots per pole per phase. For same example, of course, I have taken same example only. Effectively, how many slots we are utilizing concentrated winding? Only one slot. One slot for each phase under each pole. At the north pole, I am using only one slot for R phase. Similarly, one slot for Y phase. That is a phase belt. M is equal to 1 for concentrated. But earlier, M is equal to how many? 3. 3 we have used. For distributed winding, R phase winding is distributed 1, 2, 3. 3 slots. R1, R2, R3 we are distributing. Then, when it is said to be distributed, minimum slots at least, R phase winding has to be distributed at least 2 slots. Under north pole, if you keep R1 and R2, minimum is 2 slots. More than any number, 3, 4, 5, 6, 5, well and good. But we have shown it is 3. Okay? Yeah. So whenever you are solving the problem, concentrated winding is given, M to be taken 1 only. By calculation, data, if you calculate slots per pole per phase, some 4 you may get. But while you are substituting in the equation, concentrated, M to be taken 1. That we are going to see again while doing the problem. This is an important conclusion. Okay? Yes. Now, see, the distributed and concentrated winding, when winding is distributed, if you take induced EMF is, in this induced EMF is E1, E1, E2, E3, R phase winding, E1, E2, E3. Similarly, this side E1 dash, E2 dash, E3 dash. E1 induced EMF in the first coil, E2 second coil, third coil. Will be there any phase difference between E1, E2 and E3? Will they have any phase difference or not? Definitely they will have, definitely. E1, E2, E3, E1, 2. If this is E1, say, E1, E2 will have a phase difference and E3 will have a phase difference. Correct? Definitely. Why? Because they kept under the side-by-side slots. Side-by-side slots. Phase difference. Though they belongs to same phase, even all there belongs to same phase. R phase coils only. Even E2, E3 related to R phase. But they are kept in the side-by-side means space displacement is there. And space displacement means phase displacement will comes into picture. Phase displacement will comes into picture. So E1, E2, E3 angle will be how much angle? That is gamma. That is itself called what? Gamma. This is gamma and this is also gamma. Gamma. Whereas if you go for concentrator winding also, this is E1 say. Induced EMF is E1, E2 and E3 say. R1, R2, R3 in the first coil, E1, E2, E3. But what is the phase difference for E1 and E2? This is E1 and E2, E3. There is no phase difference. Why? Why? Because all they have kept under the same slot. Same slots means induced EMF in 3 coils, all they will be in same phase. Same phase. Same phase means if 3 coils are connected in series, what is the net voltage? Arithmetic sum. Concentrated winding, arithmetic. But when winding is distributed, it is vector sum. Vector sum. Okay. For constant distributed winding, what we have taken, let me take only 3 coils, R phase. Only for R phase, if you take R phase winding, we are keeping here 1, 2, 3, no, like that. Remaining slots also. So R phase winding is kept in the 3 slots now. Yes, this is R phase winding. R phase winding that has kept in the 3 slots. This is R1, R2, R3. So R1, R2, R3. Say induced EMF is E1, E2 and E3. E3. These are the 3 coils. 3 coils. But these 3 coils are connected in series. Say 3 coils, they will have a phase difference. What is the phase difference between those? Phase difference between them will be E1 and E2 will have a phase difference. But this is E1. E1 and E2 will have a phase difference. This is E1, say. E1 and E2. This is E2. This is E3. Phase difference. That is equal to how much? Gamma. This is gamma. This is also gamma. Gamma. And when these 3 coils are connected in series, we are connecting 3 coils. 3 coils in series. R1, R2, R3. When 3 coils are connected in series, induced EMF in each coil is E1. This is E2. This is E3, say E3. Then what is the resultant voltage? ER is equal to how much? 3 coils are connected in series. What will be the resultant voltage? Resultant voltage is sum of all E1, E2, E3. They will have a phase difference. This is E1. Okay. This is E1. And E2, I am adding E2. This is E2. And this is E3. 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 Okay. E3. Now this is the resultant. What is the resultant? This is the resultant. ER. ER. It is said to be vector sum. It is vector sum, no? Vector sum. Vector sum for distributed winding. For distributed. Okay. Are you getting how I am adding? How I am adding? See, E1 is there now. E2 I am adding like this in phase. E2 and E3 like this. This is E2. and this is E3. Now add all these things. That is nothing but resultant. Tip to tip you have to add. E1 is there, na? E2 will be added from the tip of E2, E3, like that. But resultant is vector sum. This is for what? Distributed winding. Okay. This is for distributed winding. For distributed winding. If you take for concentrated winding, what is going to happen? Same data, take for concentrated winding. Yeah. For concentrated winding, all coils. Again, 1, 2, 3, 4, 5, 6, 7. No? Yes. But where we are keeping R phase winding? R phase winding, we are keeping all the coils only in one slot. We are keeping all the coils only in one slot for R phase winding. Okay. All they have kept in only one slot. R1, R2, R3. Kept in only one slot. And their EMFs are E1, E2, E3. E3, 3 coils. There is no phase difference. There is no phase difference. And all 3 coils again connected in series. 1, 2, 3. Connected in series. This is E1, E2, E3. E1, E2, E3. The resultant is ER. Resultant is ER. ER. But there is no phase difference. Na? E1 to E2, there is no phase difference. E1 to E2, no phase difference. E1 to E2, this is E1, say. E1. E1. E2, same phase. E3, same phase. Same phase. Right? For example, E1 is equal to E, E2 is equal to E, E3 is equal to E. What is the resultant? Resultant will be, if you connect all 3 will be in series. This is 1, and this is 1, and this is 1. This is ER. ER is equal to 3E. ER is equal to 3E. Okay, that is ER. ER is equal to 3E. ER. That is, can I say it is arithmetic sum? Yes, arithmetic sum. Arithmetic sum. So when winding is concentrated, distributed is vector sum. Winding is concentrated, it is arithmetic sum. Arithmetic sum. Arithmetic sum. Fine. See, definitely vector sum is less than the arithmetic sum, na? Vector sum will be always less than the arithmetic sum. The EMF per coil will be same. For example, for concentrated winding, the induced EMF, concentrated winding induced EMF in each coil is equal to 10 volts, say. This here, 10 volts. 10, 10, 10. How much? 30 volts. 30 volts here. Arithmetic sum when concentrated. Coming to distributed winding, here also E1 10 volts, E2 10 volts, E3 10 volts. This is also E1 10, E2 10, E3 10. But ER, is it 30 or less than 30? Definitely less than 30. Definitely less than 30. The vector sum is always less than the arithmetic sum. Arithmetic sum. So when winding is distributed, it is confirmed that when winding is distributed, net EMF will reduce. Net EMF will reduce. But how much it will reduce? How much it is reduced? That is given by a factor is called distribution factor. Therefore, distribution factor is nothing but induced EMF for distributed winding to induced EMF for concentrated winding. Distribution factor is the ratio of, it is the ratio of induced EMF for distributed to induced EMF for concentrated winding, or vector sum of induced EMF divided by arithmetic sum of induced EMF. Therefore, let us define distribution factor. Now coming to the distribution factor. The distribution factor, or it can also be called as spread factor, or belt factor, or breadth factor also, breadth factor. You should be aware about all the terminology. That is KD. Distribution factor, spread factor, belt factor, breadth factor. That is KD. So KD is a ratio of induced EMF. Now I am defining KD. It is the ratio of induced EMF for distributed to concentrated ratio. The induced EMF for distributed winding, divided by the induced EMF for concentrated winding. The induced EMF for concentrated winding. Induced EMF for concentrated winding. The same also you can write the vector sum of induced EMF by arithmetic sum of induced EMF. The arithmetic sum of induced EMF. Arithmetic sum of induced EMF. That KD is equal to sin m gamma by 2 divided by m sin gamma by 2. No derivation is required. Just remember. This is KD. KD is equal to sin m gamma by 2 divided by m sin gamma by 2. Distribution factor for nth harmonic, say KDN. KDN, that is equal to sin mn gamma by 2 divided by m sin n gamma by 2. Sin n gamma by 2. Okay, this is a KDN. Distribution factor for nth harmonic. Distribution factor for nth harmonic. It's for nth harmonic. Nth harmonic, whereas this is for fundamental. Fundamental distribution factor, nth harmonic distribution factor. So KD is equal to sin m gamma by 2 divided by m sin gamma by 2. No derivation, but for ESC students, I will do the derivations after prelims examination. After prelims, before main examination, we are going to see all the derivations and also conventional type of problems, big problems. Until that, not required. Okay, I am going to derive only some important equations. Yeah. Here only the students will raise a doubt. KDN is equal to sin m n gamma by 2, m sin n gamma by 2. Is it correct, or m into n here? The denominator sin m n gamma by 2, this is only simply m I have written, not m into n. Where gamma is there, multiply with n, that's all. For nth harmonic is there, na? Gamma becomes n gamma, n times. Angles are multiplied with n. That's the reason here m gamma becomes n gamma by 2. Okay. In the denominator, m is as it is. Sin n gamma by 2. Where angles are multiplied with n. That's the distribution factor. Okay. And the distribution factor KD, the KD will be less than or equal to 1. Less than or equal to 1. And KD is equal to 1 for concentrated winding. KD is equal to 1 for concentrated winding. For concentrated winding, KD1 is equal to, KD3 is equal to, KD5 is equal to dash 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 KDN. All they are equal to 1 only. 1 only. For concentrated 1. KD1, KD3, KD5, all they are equal to 1. Why tell me? Because M is equal to 1. To substitute M is equal to 1 there. KD how much? KD becomes 1. Correct? KD is equal to sin M gamma by 2 by M sin gamma by 2. Substitute here, what is going to happen? 1 it becomes. M. M1 means sin gamma by 2 divided by sin gamma by 2. Numerator, denominator both are equal to 1. 1. Even nth harmonic. Whereas KD will be less than 1. KD less than 1 for distributed winding. For distributed winding. KD less than 1 for distributed winding. KD1 also less than 1. KD3 also less than 1. Like KD, all they are less than 1. Less than 1. But among these, which is greater? KD1 is greater normally. KD3, KD5. KD1 is greater generally. Distribution factor. Okay. On this KD, calculation of distribution factor is also part of the EMF equation problem. KD compulsory you need to calculate formula based. Sin M gamma by 2, M sin gamma by 2. Okay. See, I will give you a simple question. Taken? The question is, one of the examination, your question is like this. A three-phase alternator with slots per pole. Slots per pole is equal to 3. Then the distribution factor is. Distribution factor is A bit 0.9, B bit 0.95, C bit 1, D bit 1.5. What is the equation? Tell me what is the answer? A three-phase alternator with slots per pole per phase 3. Then the distribution factor is Distribution factor is 1. Why? Because see, slots per pole is given 3. Then what is the slots per pole per phase? Slots per pole per phase SPPM is equal to 3 by 3. Into slots per pole 3, per phase means by 3. 1 na? Yes. Since M is equal to 1, it is concentrated winding. Therefore, KD is equal to 1. KD1, you will get 1. M is equal to 1 means KD1. You substitute in the relation also, you will get the same thing. We don't know gamma, nothing. We don't know gamma. Not required. Sin m gamma by 2 m sin gamma. He has not given gamma. Is given only m. M is 1 means it is understood that automatically concentrated winding. So KD1 only you will get. Okay. Next, let me give another question. I want to give ESE 2016 examination question. 2016 examination question. A three-phase 4-pole 36 slot alternator. 36 slot alternator. The third harmonic belt factor is. The third harmonic belt factor is. Third harmonic belt factor is 0.42 B bit, 0.52 C bit, 0.67 D bit, 0.72. A three-phase 4-pole 36 slot alternator. Third harmonic belt factor is. Okay. Third harmonic KD3 you need to calculate, right? Let us see. What is the answer? Answer is C. Here, slots per pole per phase. SPP, that is M. M is equal to how much? Total slots 36. Slots per pole per phase. 36 slots per pole 4 per phase 3 is equal to how much? 3. M is 3. Now slot angle gamma. Gamma is equal to P into 180 by S. P into 180 by S. P is 4 into 180 by 36. Gamma is 20. Okay, gamma 20. Then KD. KD3. KD3 is equal to sin mn gamma by 2 divided by m sin n gamma by 2. N gamma by 2. So substitute in this. Sin m is how much? M is 3. N also 3. Gamma 20 degrees by 2 divided by m is 3 into sin n gamma by 2. N is 3 into 20 by 2. Correct? Yes. That is nothing but how much this is? This is sin 90 divided by 3 into sin 30. That is equal to, sin 90 how much? 1. 1 divided by 3 into sin 30, 1 by 2 is equal to how much? It will be 2 by 3. 2 by 3 means 0.67. 0.67. So your answer is 0.67. 0.67. Okay. So these are the simple questions, just substitutions. ESE examination, no calculator in the prelims. This type of questions can be given. The top question also is simple one. Next, I want to discuss some typical questions. Otherwise, all problems are substitutions. Formula based, it is okay. Everybody can do. No coaching, nothing is required. Simply you calculate m value, gamma value, substitute it, you will get some answer. Okay. That is very important. And let us see some in competitive examination, what type of questions that will be given. So let us take. I'm going to get the relations between various phases. Relations between various phases. The questions are, listen. The question is going to be like this. Here, students, concentrate, focus. A three-phase alternator is already there. A three-phase alternator, 300 kVA. A three-phase alternator, 300 kVA. It is converted to single-phase alternator. What is the kVA rating? What is the generated EMF when compared with three-phase? Three-phase alternator already there. Now rewound for single-phase. Can you convert? Already three-phase alternator is there. Can you convert? Can you wound for single-phase? Yes, yes. For three-phase, what we have done? R1, R1 dash, R2, R2 dash, R3 dash. That is one phase. Similarly, Y1, Y2 dash, Y2, like that. B phase. That is three phase. Instead of that, so total 9 coils are there. 9 coil sides here, 9 coil sides here. But if you connect all coils in series, that is becomes it is single phase. And instead of dividing into 3 coils for R phase, Y phase, B phase, of course we are keeping those R phase to Y phase 120, Y phase B phase 120. Now it is a three phase. Instead of that, connecting all coils. 9 coils are there. No? 9 coils, 9. If you connect all coils in series, that becomes single phase. The three-phase alternator can be converted to single phase. Same alternator, same number of slots. If three-phase is 300 kVA, when it is converted to single phase, what is the kVA rating? What is the power output? What is the generated EMF? Or if it is converted to two phases, say already three phase is there, you can convert that into two phase. Then what is the kVA rating? What is the power output? What is the generated EMF? Right? This is a comparison. We are going to get the relations between three phase, two phase, and single phase. So next important discussion is relations between various phases. Relations between various phases. Relations between various phases. Okay. First, KD distribution factor is equal to sin m gamma by 2 divided by m sin gamma by 2. Distribution factor KD sin m gamma by 2 divided by m sin gamma by 2. KD 60 is equal to KD suffix 60 means distribution factor for 60 degrees phase spread. 60 degrees phase spread is for three phase machine, correct? Phase spread is equal to how much? 180 by n. Three phase spread 60, single phase 180, two phase 90. So I am writing KD 60 is equal to sin 60 by 2, sin 60 by 2 divided by m suffix 60 sin gamma by 2, sin gamma by 2. First let me write KD 60 sin 60 by 2 divided by m suffix 60 sin gamma by 2. Am I correct? Because where m gamma is there, I am writing, where m gamma is there, now that I am writing as a 60. Is m gamma is there, m gamma. This m gamma I am writing as a 60. That's all. M gamma I am writing 60. 60 degrees phase spread. Sin 60 by 2 divided by m suffix 60. M suffix 60, how much? In earlier example, 3. For three phase machine, 60 degrees phase spread. Phase belt, how much? 3 slots. 3 slots. Sin gamma by 2. Similarly, if you write for KD 180, see single phase, I am going to write KD 180. KD 180 is equal to sin m gamma. M gamma place I am writing 180. The phase spread is nothing but m gamma. In the place of that, sin m gamma by 2, sin 180 by 2 divided by m suffix 180. M suffix 180 into sin gamma by 2. Sin gamma by 2. Like if you want to write KD 90, KD 90 means sin 90 by 2, m suffix 90 into sin gamma by 2. Okay? Nothing is there. Where m gamma is there, 90 అయితే 90 I will write, 60 అయితే 60 I will write. Okay. In earlier example, what is M60 for three-phase machine? Okay, for three-phase machine, for three-phase 60 degrees phase spread. For three-phase, what is M suffix 60? Earlier we have got M suffix 60 is equal to 3 slots. 3 slots. M suffix 60, 3 slots. So that what is its M gamma? M into gamma is equal to 3 into 20. That is equal to 60 degrees. 60 degrees. Phase spread. This is a phase spread. But M suffix 180, how much? If you want a single phase alternator, M suffix 180 is for single phase. Single phase, how many slots are required? 9 slots are required. 9 slots. Why? Because all north pole is related to only one phase. I told you, 9 coils will come for single phase means 9 coils. But all 9 coils are connected in series. 1, 1 dash, 2, 2 dash, 3, 3 dash. That is itself single phase. 3 phase, we are dividing 3 for R phase, 3 for Y phase, 3 for B phase. So for single phase means all 9 coils belongs to only 9 slots belongs to only one phase. Therefore, M suffix 180 becomes 9 slots. So that what is M gamma? M is 9 into 20 is equal to, it will be 180 degrees phase spread. This is phase spread. This is for 3 phase. This is for 3 phase. What about this is for single phase? Single phase. Right? Single phase. In this example, now compulsory for 180 degrees means more slots are required. More slots. Yeah. If you take ratio between KD 60 by KD 180, how to write? This is important. KD 60 by KD 180 is equal to, dear students, see, concentrate, focus. Don't worry. Finally, we are going to get a simple form. What I am trying to do is, now all these things you need not to be remember all. Final conclusions we are going to come. It becomes only single step problems. This kind of problems, single step problems. But for that, so how it is coming, I am explaining. Okay? Yeah. See, KD 60 divided by KD 180 is equal to, how to write? KD 60 by KD 180 is equal to sin 60 divided by 2, sin 60 by 2 divided by sin 180 by 2. Sin 60 by 2 divided by M suffix 60 sin gamma by 2 divided by sin 180 by 2 divided by M suffix 180 into sin gamma by 2. Sin gamma by 2. Right? Yes. KD 60 by KD 180. That is equal to sin 60 by 2. Sin 60 by 2 divided by sin 180 by 2. Sin 60 by 2, sin 180 by 2 into M suffix 180 by M suffix 60. 60. Sin gamma by 2 will get cancelled. Correct? Sin gamma by 2 will get cancelled. So, see, this is equal to sin 60 by 2 divided by sin 180 by 2, and instead of M suffix 180, can I write it is 180? That is equal to into 180 by 60, directly I will write 180 by 60. 180 by 60. Okay. Why 180 by 60? Why? Because see from these things, m suffix 180 divided by m suffix 60 is equal to 9 by 3. 9 by 3 means it is equal to 3, na? Yes, 3. Can I write it is equal to 180 by 60? Yes, 180 by 60, like this. See, this is the thing. From this, m suffix 180 by m suffix 60, can I write 180 by 60? Yes, that's what I am writing. M suffix 180 divided by. Okay, are you getting? Sin 60 by 2, sin 180 by 2 into m suffix 180 by m suffix 60. In place of that, simply I am writing 180 by 60. Why? Because in the data, you won't give how many slots, this, that. 3-phase alternator 300 kVA. Single phase, how much? That's all. You want to provide the M, how many number of slots, so all those things. But without that, any slots, any data you take, this relation will be valid. Okay. That is equal to how much it is? Sin 60 by 2, sin 180 by 2. Sin 60 by 2 is equal to 1 by 2, 1 into 3 is equal to how much? 1.5. 1.5. 1.5. So here what I am expecting from you is how to write this, dear students. How to write KD 60 by KD 180 is equal to C. See, KD 60 by KD 180 is equal to sin 60 by 2 divided by sin 180 by 2 into 180 by 60. That's what I want. Okay, sin 60 by 2. For example, I will ask, how can you write this relation? KD 60 by KD 90. Tell me how to write. KD 60 by KD 90, sin 60 by 2 divided by sin 90 by 2 into sin 60 by 2 divided by sin 90 by 2 into 90 by 60. That's all. 90 by 60. 90 by 60. The relations. That's all. Okay. Now why I am trying to write this? Because all that proportional to generated EMF, kVA, all that proportional to KD. See, this point is clear, na? Okay. Next. Listen. E is proportional to induced EMF and kVA rating. kVA rating is proportional to KD. Power output also proportional to KD. Induced EMF also EPH proportional to KD into turns per phase. KD into turns per phase. This I am going to prove at the end. kVA proportional to KD. Power output proportional to KD. EPH is proportional to KD into number of turns. Turns per phase. Turns per phase. So first let me write relation between 3-phase and single phase. 3-phase and single phase I am writing. kVA 60 for 3-phase divided by kVA 180 for single phase. I am writing kVA for 60 degrees and a 3-phase, 180 for single phase. That is equal to also same power output for 60 degrees phase spread 3-phase by power output 180 for single phase. 180 for single phase. That is equal to kVA proportional to KD. Power also proportional to KD. Power is equal to kVA into power factor. Na? Yes, power factor may be same for 3-phase, single phase, power factor is same. So power output for 60 by power output for 180. That is equal to KD 60 by KD 180. KD 60 by KD 180. Now tell me how to write. This is important. KD 60 by KD 180. I can write sine 60 by 2 divided by sine 180 by 2 into, okay, sine 60 by 2, sine 60 by 2 divided by sine 180 by 2 into 180 by 60. 180 by 60, correct? Yes. Sine 60 by 2, sine 180 by 2 into 180 by 60. Denominator of denominator becomes numerator, no? Yes. That is equal to how much? 1 by 2 by 1 into 3 is equal to how much? 1.5. 1.5. This is the relation between single phase and three phase. Same single phase alternator, three phase converted to single phase, ratio between KVA rating, power output, ratio between three phase and single phase. Similarly, EPH 60 degrees for three phase by EPH 180 for single phase. That is equal to KD 60, okay, KD 60 divided by KD 90, KD 180. But KD into tons per phase for three phase by tons per phase for single phase. Because EPH is proportional to KD into tons. This I am going to prove it, how it is. How KVA proportional to KD, power proportional to KD, I am going to prove it. First, let me write all relations. So, KD 60, EPH, KD 60 into tons three phase, KD 180 into tons for single phase. That is equal to KD 60 divided by KD 180 into T by 3, T by 1. Where T is the total number of tons. So three phase T by 3, single phase T by 1. Getting? For example, 150 tons are there, say, dear students, total tons are 150. Total tons 150 means for three phase, 50 tons for R phase, 50 for Y phase, 50 for each phase. Single phase, I think all 150 tons related to only one phase. So T by 3, three phase, T by 1. Two phase, for two phase, I am going to write T by 2, where T is the total number of tons are same. Then only comparison is valid. All alternator, three phase, single phase, two phase, they should have total number of tons will be same. Flux per pole same. All other things are same. Then only comparison is valid. Only phase is different. Okay. This is equal to what? KD 60 by KD 180. KD 60 by KD 180 is equal to 1.5. Already we have got the above. This is 1 by 3. Is equal to how much? 0.5. Yeah. This is the relation. Is a relation for EMF relation for single phase and three phase. Okay. With the same concept, let me write for this is we have written for single phase and three phase. Now I would like to for three phase and two phase. Three phase and two phase. Three phase and two phase. See. This KD KVA 60 for three phase divided by KVA 60 for three phase divided by KVA 90 for two phase. For two phase 90. That is equal to power output 60 for three phase divided by power output 90 for two phase. 90 for two phase. That is equal to KD 60 divided by KD 90. Here you have to say how to write. This is the key point mainly. KD 60 by KD 90, how to write? If you know this pointer, nobody can stop you. Yeah, tell me. KD 60 by KD 90 means sin 60 by 2 divided by sin 90 by 2 into 90 by 60. 90 by 60. That's all. 90 by 60. That is equal to sin 60 by 2. How much? Sin 30, 1 by 2. No? 1 by 2. Sin 45, 1 by root 2. This is 1 by root 2 into 3 by 2. That will be 3 by 2. To do this, you will get it is 1.06. 1.06. That is the ratio. KVA for 3-phase to single phase, if you take, it will be this much. Okay. Now with the same concept, write for EPH. EPH 60 degrees for 3-phase divided by EPH 90 for 2-phase is equal to what? KD 60 into tons per phase for 3-phase divided by KD 90 into tons per phase for 2-phase. 90 and phase spread. 60, 90, 180. Phase spreads. That is KD 60 divided by KD 90 into T by 3 divided by T by 2. That is equal to KD 60. KD 60 how much? KD 60 by KD is equal to 1 by 2. 1 by 2 divided by 1 by root 2 into 3 by 2 into 2 by 3. Huh? How much they will be? 1 by 2 and 1 by root 2 is equal to, its value how much? Root 2, na? Yes. What is that value? 1 by 2 into root 2 is equal to 1 by root 2, na? 1 by root 2 is equal to 0.707. 0.707 the ratio. .707. Okay. Next, similarly, KVA for 3-phase to 2-phase we have written. 3-phase to single phase. Now I would like to write for 2-phase and single phase, 2-phase. KVA 90 for 2-phase divided by KVA 180 for single phase. 180 for single phase. That is equal to power output 90 for 2-phase divided by power output 180 for single phase. Okay. After this, we are going to do the problems. How simple problems are going to be. Only single step problems all these are. After getting this idea, these are just nothing. That is equal to KD 90 divided by KD 180 is equal to sin 90 by 2, correct? Sin 90 by 2 divided by sin 180 by 2 into 180 by 90. That is equal to sin 90 by 2 to 1 by root 2 divided by 1 into 180 by 90 is equal to 2. Okay, that is equal to root 2. 1.414 root 2, 1.414. Correct? This is for relation between okay. Similarly, lastly, Power output. EPH. Next EPH 90 for two phase divided by EPH 180 for single phase. That is equal to KD 90 into tons per phase for two phase divided by KD 180 into tons per phase for single phase. How much it will be? KD 90 into T by 2 divided by KD 180 into T by 1. That is equal to KD 90 how much? It is root 2. KD 90 by KD 180 root 2 into T by 2, 1 by 2 is equal to how much? 1 by root 2, 0.707. Okay. Fine. So these are the relations. I hope you got the idea how to write these relations. So like this, any number of phases may be given. You are in a position to write the relations. I have taken whatever the practical generators are existing alternator, 3-phase, 2-phase, single phase. If I may ask for 6-phase and 6 phase means what is the phase spread? 6 phase means phase spread is equal to 180 by 6, 30 degrees you will get. Now I can take KD 30 by KD 60. Or KD 60 by KD 30, that is equal to sin 60 by 2, sin 30 by 2 into 30 by 60. Same way, any number of phases. Theoretically, it can be anything. Yeah, now. Then let us see the questions. Some questions related to this, and after that we will go for break. Okay. Now 3 questions I am going to see from most competitive examination. One is GATE, one is IAS, one is IAS. 3 questions, 3 minutes. Let us see. You have taken this now? Fine. Over. Right. The questions are, the question is a 3-phase alternator with 300 kVA. 3-phase alternator with 300 kVA is rewound for single phase operation. Rewound for single phase operation. Single phase operation by utilizing all the coils. Okay. All the coils. Then the rating of the rating is single phase operation. The rating is A bit. 300 kVA, B bit. 200 kVA, C bit. 100 kVA, D bit. 150 kVA. Tell me, answer for this. Over. A 3-phase alternator with 300 kVA is rewound. It is reconnected. Same 3-phase alternator you can convert into single phase. Only end connections. For each phase 3 coils, but single phase all coils are connected in series. That is only single phase alternator. By utilizing all the coils. What is the answer? Answer is C. Solution is, we know kVA 3-phase. kVA 3-phase by kVA single phase. That is equal to KD 60 by KD 180. That is equal to how much? 1.5. Already we have got. Even if you forget, you can also write again. You need not to by heart. KD 60 by KD 180, that is equal to sin 60 by 2 sin 180 by 2 into 180 by 60. You know how to write. That is 1.5. Okay. Yeah. Now, so therefore, what is KVA three phase? KVA three phase is equal to KVA single phase. You want to write now? Yes. KVA single phase is equal to KVA three phase divided by 1.5. Yeah. KVA three phase how much? 300 KVA. 300 KVA divided by KVA single phase. That is equal to 1.5. Therefore, what is the KVA single phase? KVA single phase is equal to 300 by 1.5 is equal to 200 KVA. The 200 KVA. For three phase, 200 KVA. 200 KVA. Similarly, it's over now. 200 kV answer. Next. Another question. A three-phase alternator. Three-phase alternator with 300 kVA. 300 kVA is rewound. For two-phase operation. Two-phase operation by utilizing all the coils. Then the kVA rating is. A bit. 300 kVA, B bit. 200 kVA, C bit. 282.8 kVA, D bit. 250 kVA. 150 kVA. Okay. Three-phase alternator with 300 kVA. It is rewound for two-phase operation by utilizing all the coils. Then the kVA rating is. Right? CSE examination. Earlier one is GATE examination. GATE 99 examination. Of course, similar question 2006 also given. A three-phase alternator 300 kVA rewound for two-phase. Tell me what is the answer? Yes. Answer is, let us do this. We know that kVA three-phase by kVA two-phase. That is equal to KD 60 divided by KD 90. That we got relation 1.06. 1.06. Therefore, if you want to find kVA two-phase is equal to kVA three-phase divided by 1.06. So kVA three-phase is given 300 kVA by 1.06. How much? It will be 282.8 kVA. Of course, approximately it is 283 kVA. 283 kVA. 283 kVA. 283. Similarly, let me give. You have taken, na? Yeah. Next question is. Next question. Answer is what? 282.8 kVA. Next question. Next question is, this is a GATE 2014 examination for 2 marks. 2 marks. The question is, V1 is the EMF per phase for single phase operation. Single phase operation. V2 is the EMF per phase. EMF per phase for 3 phase operation. 3 phase operation. 3 phase operation. Then V1 by V2. V1 by V2 is A bit. A bit. 1 by 2, B bit to 2, C bit. 1 by root 2, D bit. Root 2. Root 2. Tell me answer for that. 2 marks question. Actually, he has given total elaborate data. V1 by V2. What is your answer? Okay. Answer is For that, see. So we know 3 phase voltages kada? Yes. EPH 3 phase 60 degrees for 3 phase divided by EPH 180 for single phase. We know that relation. How much it is equal to? That is only is giving V2 by V1. V2 by V1 is equal to, we know what is the ratio we have got already. It is 0.5 now, 0.5. But he is asking V1 by V2 is equal to 1 by 0.5 is equal to how much? 2. Answer is 2. 2. We know the relation already. 3 phase to single phase. What is the voltage ratio? 0.5. 0.5. Okay. V1 by V2 is 2. Right? Yeah. Okay. So these kind of questions, these are single step questions. Only EPH is proportional to KD into tons per phase and KVA proportional to K. Yeah. One observation you might have got here. See, the observation is same problem we have done. Na? Yes. Same problem, single phase. Same problem. For 3 phase, you have got, what is the KVA rating? KVA rating is 300 KVA. 300 KVA. But for 2 phase, it is 283 KVA. 83 KVA. Single phase, how much? 200 KVA. 200 KVA. Okay. 3 phase is for 60 degrees phase spread. Phase spread. This is 90 degrees phase spread. 90 degrees phase spread. And this is 180 degrees phase spread. Phase spread. Okay. From this, observation is same alternator. The 300 kV alternator is rewound for single phase. Okay, listen. Where are you? See, 3 phase alternator 300 kVA. Converted to single phase means you are getting only 200 kVA. 200 kVA. The same number of tons, flux per pole. Machine is same. When comparison means all these things will be valid for same machine. Flux per pole same, speed is same, total number of tons is same, rotation is same. So three-phase alternator 300 kVA is there. If you are converting for single phase, you are getting only 200 kVA. The loss of 100 kVA, loss of 100 kVA. That's the reason three-phase is best. Three-phase is economical. Three-phase is economical. Same winding, but you are getting more rating of the machine is more. Even for two-phase also you see. Three-phase 300 kVA, but two-phase how much? 283 kVA. Nearly 17 kVA has been reduced. Na? Yes. That's the reason three-phase generators are more famous. Three-phase generators are more famous. One three-phase is there. You can take single phase, phase neutral, between one phase, one neutral. Fine. Then why to go for single phase generators? In your house, can you purchase single phase generator? Where single phase generators is purchased? Some domestic applications, wherever single phase supplies domestic application, they will purchase. But nowadays, in your houses, you are not purchasing single phase alternator. Three phase is there, phase wire. And when power failure takes place, say, you can have, instead of your generator, simply inverters are there, inverters. Domestic applications only, single phase, very rare. Two phase also. Why two phase generators are required? To supply the two phase motors. Servo motors are there, na? Servo motors are two phase motors. Two phase induction motors are also there. Because two phase induction motors are, torque is more. 90 degrees phase difference, na? 90 degrees. Phase 1 to phase 2, 90. More torque. Like servo motors applications other. Then we will go for two phase generators. But more commonly, three phase generators are used. Three phase generators are famous. Yeah. And as phase spread increases, what is happening? From above, it can be observed. That the rating of alternator is more. Rating of alternator is more for three phase. More for three phase. Okay, yes. And another one also, rating, KVA rating and power output, they are inversely proportional to phase spread. As phase spread increases, KVA rating decreases. Correct? Phase spread. Less phase spread, more KVA rating. Phase spread 60, more KVA rating. Correct? So as phase spread increases, KVA rating will reduce. Fine? Okay. Yeah. Yes. Now, so it is better to take some time, break time. Okay. Some of you are having doubts. What is your doubts? Okay. I will attempt some doubts. Those are having. Please stay for some time. Maybe you people also having similar doubts. And after that, we will go for a break. Okay. Yeah, I would like to attend because most of the people are raising your hand, but in between I can't attempt. Otherwise, the topic will delay. Okay. Tell me what is your doubts, Bharat, Vishnu.
Sir, mine is regarding how this T per phase is becoming T and T by 3 and T by 2 for single phase, two phase, and three phase, sir.
Total turns are same. Three phase also total turns 150. Single phase also total turns 150. Say.
Yes, sir.
Total number of turns.
Okay.
Then only comparison valid. While you are comparing three phase or single phase, say total number of turns are same. Flux per pole is same. Speed is same. Total starts. Everything is same. Only connections are different.
So we are just essentially converting one machine to the other.
Yes, exactly. Or else you take three phase alternator is there, another single phase alternator. Everything is same. Total data same. Only this is designed for three phase. This is designed for single phase. Then only 150 tons are they say T by 3 tons per phase.
Yes, sir.
Tons per phase, and we are comparing with EPH.
Okay, sir. Okay, sir.
Fine. Next, hello.
No, sir.
Yeah, tell me.
My doubt is from yesterday's one, sir.
Uh,
Why do we go for double layer winding, sir?
I will come. Double layer winding only, you will get a short pitch winding. So whatever I have drawn distributed, no, that is for full pitch, no. It is single layer. If you draw for a double layer winding, distributed, under that we need to short pitch in a
Yes, sir.
distributed short pitch winding is possible only with double layer winding. Double layer, why? Because, see, for example, in this diagram, see here, dear students, others also, please stay for some time, stay back, don't leave. So this type of doubts others also may get. For example, this is my single layer winding. Na? Single layer means only one coil side is placed. R1, R2, R2. There are coil sides. One slot, only one coil side, single layer. Now, for example, I want to go for a short pitch. Where you can keep, tell me. R1 is first slot, R1 dash 10th slot, no? Full pitch.
Either in 8 or 9.
Short pitch, 9th slot, say for example. R1, instead of keeping 10th slot, I can keep 9th slot. But 9th slot already, Y must be kept, na?
Yes, sir.
Y must be kept.
Yeah.
But Y already there. For single layer, say Y already there. How can you keep R1 dash? Where you can keep?
So I have to use double layer.
Y I can keep top and Y R1 dash I will keep in the bottom layer.
Okay.
Short pitch winding is possible only with double layer. That's the reason alternates are, they will definitely double layer winding. Short pitch winding is possible only with double layer winding. Cross surrender. I will write short pitch winding is possible only with double layer winding. Double layer winding. Okay. Yes. But if I double layer winding, this entire thing is going to be confused. That's the reason I don't want to make still complex. This is itself still complex. And again, if I add double, anyhow, I am going to draw the double layer winding also at the end. Double layer winding, 120 degrees phase spread. Okay, topic wise, I will go step by step. Let us go. If I include all the things, it will become clumsy and it is highly difficult to understand. That's the reason I am going very step by step. Okay. Yeah, tell me.
So one more doubt is, what will the approximate number of turns in coils?
Approximately, we cannot say. A coil may have 5 turns. A coil may have 10 turns also. Generally 10, 20 will be there. It is depends on the size, rating of the machine.
Okay.
And that to be turns is not small wires, thick bars. I have shown the very
just to withstand the high current.
Yes. Very high current means conductors are like plates, thick plates there.
Yes, so we have seen that in the diagram.
Yes.
I had no idea about that.
Rating. It is depends on the rating. If large alternates means more turns will be there, definitely. Yeah.
Okay, sir.
Each coil may have 10 tons also, 10 tons, 20 tons also. Okay, right. Next.
Sir,
tell me.
Sir, just one thing is regarding this hunting phenomena, sir.
Oh, hunting we can discuss. Now, this class, you please tell me because others also.
No, sir, I'll ask at the end.
Okay. Hunting you can ask some other time because we will disconnect to the point. Okay, next. Related to this topic, it is better. But others also can. Yeah, anyone? Hello?
Hello, sir.
Tell me.
Sir, for phase spread is 60 degree, no, sir?
Yes.
That is, we are considering for slot 18 slots only, no, sir?
Any number of slots you take, you will get 60 only.
Okay, sir.
If you take, your doubt is, if I take 36 slots, correct?
Yes, sir.
2 pole 36 slots. 36 slots if you take, right? What is the slot angle? Gamma you will get 15 degrees.
Okay.
15.
Okay, sir.
Okay. Now total 36 slots means under North Pole how many? Under North Pole you will get 18 slots. So South Pole 18 slots. Simply you are doing double slots. Say for example 36 slots. 36 means 18 for North Pole, 18 for South Pole.
Okay.
But what is the slot angle 15? Slot angle 15 means how much slot angle 15? 10, sorry. 10, no?
Yes, sir.
Slot angle 10. 10 means how many slots are required for R phase? How many slots? 6 slots are required.
Yes, sir. 6 into 15.
Okay. See, let me draw here. Your doubt is understood. Your doubt is like this. If a 3-phase, 2-pole, 36 slots, okay? 36 slots. 36 slots means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, dash. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But anyhow, 9 slots for North Pole, not 9. 18 slots for North Pole, 18 slots for South Pole. This remaining South Pole. Okay, right? But what is the gamma you calculate? Gamma is equal to how much?
180 by.
Gamma is equal to 180 by S by P. But what is the slots per pole? Slots per pole is equal to 9. 18. 36 by 2, 18. Okay.
180 by.
Slots per pole per phase how much? SPP. SPP is equal to 36 divided by slots per pole 2 per phase 3. How much it is?
6.
6. And what is gamma? Gamma is equal to P into 180 by S. So gamma is equal to 2 into 180 divided by 36. How much it is? 10 degrees. 10 degrees. Okay. Now see, slots per pole per phase 6. 6 means how many slots you have to keep? R1, R2, R3, R4, R5, R6 will come. 6, no? Yes. But 6 means this is 6 slots are there. 1, 2, 3, 4, 5, 6 slots are there. 6 slots means what is the angle for each slot?
10 degrees.
10 degrees. How much angle it is?
60
degrees only, no?
Yes,
That is M gamma, phase spread. You take any number of slots, that discussion is valid.
Okay, sir.
Okay. I have taken minimum number of slots. 18 I have taken for comfortably, reasonably minimum slots. But this discussion is valid for general for anyway. Okay.
Thank you, sir.
Yeah. Now.
Hello, sir.
Yeah. Tell me.
Sir, we have obtained the standard relations between EPH 30 or EPH 60.
Yes.
Sir, in that relations, sir, how we have taken the angle for means 90 degree, 60 degree, 30 degree? For that?
60 degree 3-phase machine. What is a phase spread?
Sir,
KD 60 means why 60 coming 3-phase, it is 60 only will come. Any data you take, this is what I have shown now, 60 degrees only you will get for each phase. There is a phase spread.
sir, but for a 2-phase and a single phase, we have taken 90 and
Yes.
180, sir.
Yes. Single phase, same data. Single phase means you can keep all coil sets only in one slot. For example, you want to draw the single phase winding. How it will be? Single phase winding. All coils will be connected in series. For example, this is one coil 1. Yes, coil 2 will be here. Coil 2 and coil 3, coil 4, 3. All they will be connected in series. All they are connected in series.
Yes.
This is only single phase. Like that, keep on going and finally you will get to 1 dash lastly. But how many slots are required for single phase? Tell me. 18 slots are required. And in this example, earlier example, how many slots are required for single phase? 9 slots are required. In our question, in our discussion, this is there, na? In this, if you
Yes,
draw,
sir,
I have drawn for 3 phase. Single phase means if R1 instead of R1, 1 dash, 1 dash, 2 dash, 3 dash, 4. All coils will be connected in series. One beginning, one ending. But all north pole is related to only single phase. At north pole, how many slots are there? 9 is there. 9 slots means how much angle? 9 into 20 is equal to 180. That's what. Single phase 180. So pole pitch 180 by N I have given that 180 is poles. if north pole, three phases are there, three phases are equally shared. That 60, 60, 60 for each phase. 60 for R phase, 60 for Y phase, 60 for B phase. Okay.
Okay,
Next, single phase means total pole is related to only one phase. One phase and all coils are connected in series. That's all. Okay. Yeah.
yes.
Now it will be better. Hello. Anyone is there last doubt? And we'll go for a break. Okay. Let us go for a break. Yeah, let us go for a break and then break for 20 minutes. Yes, 7:50 now. Break. $7:50. 8:10. Class will start at 8:10. Take the break and then come back. Okay. Yes. Fine. Yeah. Okay. See, dear students, I have given the ratio. So you may express a doubt. Sir, how you have given KVA proportional to KD? Okay. And EPH is proportional to KD into number of tons. Just let me prove how it is. Why KV? How it is? Why KVA and power output? KVA proportional to KD, and EPH is proportional to KD into tons per phase. Let us see. Earlier we have gone through all these things. Na? Reason is KVA, yeah, EPH. Reason is, we know that EPH is equal to what? 4.44 Kp Kd 5F TPH. 4.44 Kp Kd 5F TPH. EMF per phase is equal to Kp Kd 5F TPH. But in this, when we are doing the comparison, comparison for single phase and three phase, Kp will be taken same. Because single phase also can have alpha 30, two phase also 30, three phase also 30. Then only your comparison valid. But single phase alternator alpha different to three phase alpha different means then you cannot compare EPH. Provided that other things are same. Short pitch winding angle is same. So therefore Kp same. Is the Kd is the same? Huh? No, Kd will be different for phases. Because Kd is equal to sin m gamma by 2 divided by m sin gamma by 2. So Kd involving m term. M means slots per pole per phase. So as single phase and three phase changes, Kd will be different. Kd is not same. Flux per pole same. In all alternator, we are taking flux per pole same. Frequency also same. Speed is same. Now, what is then EPH is proportional to only KD and TPH, KD into TPH. EPH is proportional to KD into tons per phase. Okay. And when EPH is proportional to KD into tons per phase, why KVA is only proportional to KD? Actually, we know that KVA is voltage into current, But voltage is proportional to KD into tons per phase. But why KVA is where is the tons per phase is going? Right? Let me show that. I want to take this is EPH proportional to KD into tons per phase. Okay. Let us compare KVA for three phase by KVA for two phase. Okay. KVA three phase means KD 60. It is KVA three phase to KVA single phase. Is nothing but 3 EPH 60 for three phase into KD 60, not KD 60, IAPH. This is nothing but IAPH for 60 degrees phase spread. IA for three phase. IA for three phase. Okay. KVA is nothing but voltage into current. 3 EPH. The total KVA is equal to what? 3 into EPH into IPH. But whereas for single phase or two phase, 2 into EPH 90 for two phase into IAPH for two phase. IAPH for two phase. And here the currents to be taken same. Currents for two phase and three phase we need to take same, because same coils we are using, same conductor. But this is one coil, say. If you use three phase also it can carry same current. Two phase also it can carry same current. Two phase also it can carry same current. Single phase also. Same winding we are using. Na? Same winding we are using means only number of turns we are changing per phase. So for example, three phase, total 150 turns. 150 turns means for each phase 50. That 50 turns connected in series. If they carry, each turn carry some 10 amperes, say, and when you are connecting for two phase, 150, they are divided into half, 75, 75. 75 turns are connected in series. But how much current each turn will carry? 10 amperes only. Current rating is same, because same winding we are utilizing. Only number of turns connected in series is more. EMF will be changes, current is not changes. So therefore, yeah, this is equal to 3 EPH 60 for three phase divided by 2 EPH 90 for two phase. Okay. This is equal to, we can write, this is equal to 3 into EPH 60. Just a minute. We are going to next step will be clear. Yeah, that is equal to 3 into EPH 60 for three phase divided by 2 into EPH 90 for two phase. 90 for two phase. Currents are same. Currents will be same. Only number of turns per phase is more, but same turns we are using, current rating same. That is equal to 3 into EPH 60 means what? EPH 60 is KD 60 into turns per phase. Turns per phase, no? Yes. Turns per phase for three phase. Divided by 2 into KD 90 into turns per phase for two phase. I am comparing three phase and two phase. That is 3 into KD 60 into T by 3 divided by 2 into KD 90 into T by 2. So then finally what was happened is 3 with 3 will get cancelled, 2 will get cancelled, T will get cancelled. So finally what you will get, that is equal to KD 60 divided by KD 90. Therefore KVA 60 for three phase divided by KVA 90 for two phase is equal to, simply it is KD 60 by KD 90. It is not consisting of turns per phase. Where turns per phase has gone? It is T by 3. 3 into there, not 3 into T by 3. 3 into T by 3. Okay? Yes. MF KD into turns per phase. But KVA rating 3 becomes T by 3. That 3 this is what will get cancelled. Okay? Yeah. Now, next concept is taken. Right. Now let us do the one problem on this. Okay. And before going to the problem, let us see another important topic. 120 degrees phase spread. You have taken this now? Okay. See, for three phase alternator, there are two phase spreads. For three phase alternator, there are two phase spread. One is 60 degrees phase spread, another one is 120 degrees phase spread. 60 degrees phase spread is called a narrow phase spread. 120 degrees phase spread is called wide phase spread. Wide phase spread. That is only for three-phase machine. For three-phase alternator, for three-phase machines, there are two phase spreads. There are two phase spreads. Two phase spreads. Number one is 60 degrees phase spread. 60 degrees phase spread called narrow phase spread. This is also called what? Narrow phase spread. Narrow phase spread. And second one is 120 degrees phase spread. 120 degrees phase spread, that is wide phase spread. Wide phase spread. Wide phase spread. 60 degrees phase spread, narrow phase spread. 120 degrees phase spread is called wide phase spread. 60 degrees phase spread is more commonly used. 60 degrees phase spread is more common. Is more commonly used. More commonly used. Whereas 120 degrees phase spread is rarely used. 120 degrees phase spread is rarely used. Rarely used. To eliminate triplen harmonics. To eliminate triplen harmonics in phases. Triplen harmonics in phase voltages. Triplen harmonics in phase voltages. We eliminate triplen harmonics in the phase voltages. 120 degrees phase spread is used. But 60 is more common. 60 is more common. 120 degrees phase spread is rarely used. But how? With 120, okay? With 120 degrees phase spread, how triplen harmonics are eliminated? How triplen harmonics eliminated? Eliminated. For that, you can see here, reason is, if phase spread, m gamma, phase spread, m gamma is equal to 120 degrees you take, m gamma 120, then you calculate KD3, KDN is equal to how much? KD3 is equal to sine mn gamma by 2 divided by m sine n gamma by 2. N gamma by 2. Okay. KD3. Sin m n gamma by 2, m sin n gamma by 2. That is equal to, I can write sin, okay, n into m gamma by 2 divided by m into sin n gamma by 2. That is equal to sin n is 3. Third harmonic na n is 3. But gamma 120 by 2 divided by this m sin n gamma by 2. That is equal to how much? That is 0. KD3 is 0. Therefore, KD3 0 means, then what is EPH3? Third harmonic voltage also 0. Eliminated. 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 Similarly, KD9 also 0. KD15 also 0. All triplen harmonics will be eliminated. All triplen harmonics will be eliminated. Okay. Yes, all triplen harmonics will be eliminated. Okay. Yes, all triplen harmonics eliminated. M gamma you take 120, everything eliminated. Okay. But how 120 degrees phase spread is possible? 120 degrees phase spread. See, okay. 120 degrees phase spread means this is you have taken, na? Yeah, right. I'm not going to draw the entire diagram. For example, earlier same example only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, say for example 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Under this, 9 slots for North Pole, 9 slots for South Pole. Okay. But R phase winding, what is gamma here? Gamma. I'm taking a 3-phase, 2-pole, 18-slot alternator. 18-slot alternator. What is gamma? Tell me. Gamma 20 degrees, na? Gamma 20. Gamma 20. Gamma 20 means if you want a 60 degrees phase spread. For 60 degrees phase spread, how many slots we can keep our winding? For 60 degrees phase spread, say, we can keep the winding in 3 slots. 3 slots. 1, 2, 3. This is 60 degrees phase spread. For 60 degrees phase spread, 3 slots. 60 degrees phase spread. Whereas, if you want 120 degrees phase spread, means how many slots you can use? 120 degrees phase spread means 1, 2, 3, 4, 5, 6 slots I can use. 6 slots. 6 slots you have to keep. 1, 2, 3, 4, 5, 6 slots are required. 6 slots means then what is your phase spread? So phase spread is equal to 120 degrees phase spread. 120 degrees. See, this is 120 degrees. The 120 degrees phase spread, how many slots are required? Double that of. Double. Compulsory. 60 degrees, 3 slots say, 120 degrees, 6 is required. 6 slots are required. 6 slots. This is for R phase. 60 degrees phase spread. Okay. This R phase only. How we can keep here winding? The winding can be kept like this. Winding can be kept R1, R2, R3. Na? Yes, we are keeping R1, R2, R3. How it is? It is R1, R2, R3. But whereas here, we will keep like this. R1, R2, R3, R4, R5, R6. R6. Okay. R6. And where Y1 can be kept, tell me, Y1? Y1 will be here only. Y1 can be kept in the 7th, 8th, 9th slot. But of course, it is possible with double air winding. This is Y1, no? Y1. Well, again, this is Y1 also has to be kept, these many slots. This is Y1. Y1, Y2, Y3, Y4, Y5, Y6 we can keep. Y1, Y2, Y3, Y4, Y5, Y6. Then also the phase spread for this also how much? 120 degrees. 120 degrees. 120. That is a phase spread. Just a minute, dear students, listen. Stop writing, stop writing. Some students are asking a doubt. Sir, 120 degrees phase spread means, sir, even 120 degrees phase spread also, what is the angle between R1 to Y1? R1 to Y1 is compulsory 120 only, dear students. R1 to Y1, it must be compulsory. R1 to Y1, it must be 120. That is no doubt. That is no doubt. Okay. But this is phase spread. This is 60 degrees phase spread and this is 60 degrees phase spread. Okay. And this is 60 degrees phase spread. But whereas this is 120 degrees phase spread. 120 degrees phase spread. Okay. But whether 60 degrees phase spread also, R1 to Y1 compulsory 120, even 120 degrees phase spread also, R1 to Y1 it is must be 120 degrees. That 120 compulsory. Three-phase machine means, just a minute. Three-phase machine means R1 to Y1 compulsory it must be 120 only. Compulsory 120. Okay. R1 to Y1 120. 60 gane 120. Only phase spread is means what? Under North Pole, if 3 slots you distribute R phase winding, that is 60 degrees. Instead of that, if number of slots are double, say double, 6 slots, then it is 120 degrees. 120 degrees phase spread. Phase spread into these 3 slots, 6 slots. But R1 to Y1 compulsory 120. It may be 60 or 120, whatever it may be. Winding must be balanced. Okay. Yeah. And where, dear students, I will ask one question. No, compulsory, you need to keep B phase. Where you can keep B phase? B phase. And R1 dash, for example. Where you can keep B phase? B phase must be kept in okay, you see. 10th slot is there, 10th slot already Y4 is there, Y4. But where you can keep R dash can be kept in the 10th slot in the bottom layer. Okay. But 120 degrees phase spread is possible with only double layer winding. 120 degrees phase spread is possible with double layer winding. Possible only with double layer winding. Double layer winding. Double layer winding. Double layer winding. Anyhow, I am going to draw at the time single layer and double layer 120 degrees. For this time being, you just have idea 60 degrees and 120 degrees phase spread. The rest of the things you forget about. Okay. I will give one question based on this. If I draw total diagram, then only you can understand how it is possible with double layer winding. Okay. I will draw. Not now. If I draw that, it will take its own time. Phase spread you understood na? 60. 3-phase machine, 60 degrees, 120 degrees phase spread. Okay. Now, the question is in your previous examination question. Let me come to that question number. See here. Okay. Question is a 3-phase alternator. A 3-phase alternator with 60 degrees phase spread A three-phase alternator with 60 degrees phase spread. The generated EMF is E1. The generated EMF is E1. Power output is P1. 60 degrees phase spread. The generated EMF is E1 and power output is P1. Power output is P1. For 120 degrees phase spread, E2 comma P2. Then the terms E1 comma E2 and P1 comma P2 relates as under. Okay. So A bit E1 is equal to E2 comma P1 is equal to P2. E1 is equal to E2, P1 is equal to P2. B bit E1 is equal to 1.15 E2 comma P1 is equal to 1.15 P2. C bit E2 is equal to 1.15 E1 comma P2 is equal to 1.15 P1. D bit E2 is equal to E1 comma P2 is equal to 1.15 P1. Okay. Yes. Answer is C. Solution. 60 degrees 120 and 60. First let me write for KVA. KVA 60 for three phase divided by KVA 120 also for three phase. Both are for three phase machine only. 60 and 120. That is equal to KD 60 divided by KD 120. That is equal to what? Sin 60 by 2 divided by sin 120 by 2 into 120 by 60. That is equal to 1.15. Therefore, KVA 3 phase 2. No, power is given. Power. Okay, even power I will write instead of KV, power. Power output 60 degrees for 3 phase 2. Power output 120 for 3 phase. Therefore, 3 phase means it is what? P1 by P2 is equal to 1.15. Therefore, P1 is equal to how much? P1 is equal to 1.15 P2. This is answer. One option. P1 is equal to 1.15 P2. Okay. Yeah. Next, similarly, EPH. EPH means EPH 60 for 3 phase divided by EPH 120 for 3 phase. That is equal to KD 60 divided by KD 120 into tons per phase. For 3 phase divided by tons per phase. That is also for 3 phase. It is equal to what? KD 60 by KD 120 into T by 3. That is also equal to how much? Simply it is equal to KD 60 by KD 120 is equal to how much? 1.15, 1.15, not 1.15. Therefore, that is also E1 by E2 is equal to 1.15. Therefore, E1 is equal to 1.15 E2. This is another option. So therefore, what is your answers? This one and this one. So answer is B. Answer is B. Okay. Answer is B. It may be 120 degrees or 150, whatever it may be. Power output proportional to KD, EPH proportional to KD into turns per phase. But both are three phase. So from here onwards, just remember that 120 is very rare. 120 is very rare. You keep aside. Now forget about when question is given, then only you think. Unless otherwise mentioned, three-phase machine is always 60 degrees phase spread. 60 degrees phase spread only. Okay. Yeah. I will ask for you, why 120 degrees phase spread is not preferred? Because with 120 degrees phase spread, KVA rating and power output will decrease. See, with 120 degrees phase spread, the power output, KVA rating and EPH will reduce. Okay. That's the reason 60 degrees phase spread is more famous. 60 degrees phase spread is preferred. 60 degrees phase spread is preferred. Are you observing? E1, P1 is equal to how much? 1.15 P2. P1 is equal to 1.15 P2. 15% extra. 60 degrees phase spread, the power output is extra. Okay. I mean to say, so for example, for 120 degrees phase spread, if it is for 120 degrees phase spread, say, for 120 degrees phase spread, it is 100 kVA and 10 kilovolts, say, 100 kVA and 10 kilovolts, 10 kilovolts. And for 60, how much it will be? For 60, it will be 115 kVA and 1.15, 10 point. How much? 10 kV. 10 kV means it is 11.5 kV. It will be 11.5 kV. Now you can observe here the differences. This example will give clear idea for you. And 120 is very rarely, only triplen harmonics eliminated. I have shown already. Third harmonic eliminated the phases. But with that KVA rating, power output, that will be decreased. That's the reason 120 degrees phase spread is not used, very rarely used. Okay, right. This information enough. With 120 degrees phase spread, you just have an idea about this conclusion. I don't think much again. Okay. Now let us do some problems on this EMF equation problem. I think you'll be having this material now. We have this material is being supplied for you. This one, electrical engineering, volume 1. In this, I have given all problems. Each model one problem. I have given limited number of problems only. If you do that problems is more than sufficient. It will cover everything. You are not going to miss anything. For each model, one problem I have given. Okay, that is sufficient, covering everything. So let us do one problem. Yeah, you can also find the material, but let me slide share. Now this is the time to do the problems because gate examination is nothing but numericals. We are completed KP, KD and EMF equation. Let us do the problems on EMF equation. Very important thing. So you also take your calculators and tell me the Yeah. Now, let me share this. Okay. Yes, students, can you able to see this? Yes. See, the problem, let us do this problem. Problem is, yeah, this problem, 8 to 13. The problem is 8 to 13. 8 to 13. Problem number 8 to 13. Okay. This problem, common data for question number 18 to 13. See this. A 4-pole 50 Hz synchronous generator has 48 armature slots in which double layer winding is housed. Each coil has 10 turns and short pitched by an angle to 36 degrees, alpha 36 degrees, alpha 36. Okay. Electrical angle 36 degrees. The fundamental flux per pole is given 0.25 Webers. Fundamental flux per pole is given 0.25 milliwebers. Okay. Now, under that, he has given, I have given 8 to 13, question number 8 to 13. 6 questions are given, 6 questions are being given. But first 8, question number 8, 9, 10, they are GATE examination question. GATE 2006 examination question, 8, 9, 10. For 6 marks, he has given. At that time, the problems will be triplet question. Common data, under that 3 problems, 3 into 2, each question 2 marks. But now that pattern is not there. All questions are individual questions. Okay. Now, what is the question number 8? You see, question number 8 is the line to line induced EMF for 3-phase star connected approximately. For 3-phase star connection, what is the induced EMF? 3-phase star connection, what is the induced EMF? Options, you know, 808, 888, 1400 and 1538 is given. Question number 9, you see, the line to line induced EMF for 2-phase. Question number 8, line voltage for 3-phase. And question number 9, line voltage for 2-phase. There are also options 111, 1143, 1332, 1617. Right? Next question number 10 is given, 5th harmonic component of phase EMF. What is the 5th harmonic component? For 3-phase star connection is given. 11th question, the induced EMF for single phase connection. What is the induced EMF for single phase alternator? Next, see this one, question number 12. Question number 12 is, if the turns are connected among the 2 parallel paths. 2 parallel paths for 3-phase star connection. The phase EMF and line EMF. The turns are connected among 2 parallel paths. Generally, all turns for phase connected in series only. But if they are connected in parallel, 2 parallel paths, what is the EMF line phase? EMF line phase. 13. If the turns are connected among the 2 parallel paths for 2-phase connection, phase EMF and line EMF, how much? Okay. This problem is equivalent to 6 problems. I am going to do minimum number of problems, but that covers everything. One problem only, we are covering 6, all varieties. Okay, not necessary to do so many problems. For same data, we are doing all the things. First 3 questions, GATE questions. I have added another 3 more questions. So let us do the solution. And that in this also I will write the page number. You can verify it, right? Yeah, that page number is 236 actually. Okay. Yeah. See the data given, dear students. This question number in your material you can find it is page number 237. Page number 237. Question number 8, 9, 10, 11, 12, 13. Okay. First, these questions are GATE 2006 examination for 6 marks. 6 marks. Okay. Yeah. Now, so what is the data given? Directly let me write data given. What is the data? A 3-phase. This is a question, no? Yes. That is a 3-phase. Data given is a 3-phase, 4-pole, not 3-phase, a 4-pole. A 4-pole, 50 Hz synchronous generator. Synchronous generator has 48 slots. No? Has 48 slots. In which double layer winding is housed. Each coil has 10 turns. Each coil has 10 turns. Short pitched by 36 degrees electrical. 36 degrees electrical. The alpha is equal to 36. That is alpha. 36 degrees electrical is given. 36. Fundamental flux per pole. Fundamental flux per pole. Fundamental flux per pole. That is phi. Phi is equal to how much? Phi is equal to 0.025. 0.025 Webers. 0.025 Webers. Okay. Yeah. Then question number 8 is for 3-phase. For 3-phase, line voltage how much? Question number 9 is, what is that question number 9? Question number 9 is for 2-phase. For 2-phase, what is the line voltage is? Line voltage. Question number 10, EPH5 is equal to how much? Question number 11, for single phase, EPH is how much? Okay, like that. 12 and 30. Okay. Let us do this problem completely. Of course, I am having my own solution. Yes. Yeah. See here. Yes. Okay. Right now? Yeah. First of all, dear students, see, important thing in this, each coil has 10 turns, no? Each coil has 10 turns. But how many total coils? How many total coils are there? Each coil has 10 turns, but how many coils he has not given? Coils are not given. How many coils? If you know total coils, then only you can calculate turns. But he has given 48 slots. Since it is double layer winding, since it is double layer winding, therefore number of slots is equal to number of coils is equal to number of slots. Correct? Double layer winding, number of coils is equal to number of slots. How many? 48. 48. Number of coils is equal to number of slots, 48. Okay? Yeah. And each coil has 10 tons. Each coil has 10 tons. Given 10 tons. 10 tons means, therefore, what is total number of coils? Total number of tons. Total number of tons is equal to 48 coils are there, na? 48 into 10. That is equal to 480. Total number of tons are 480 tons. This is common. Total number of tons are 480. Okay. That 480 tons are common for all the problems, all 6 problems. These are tons. Now let us do for first question, question number 8. Let me do first question number 8. Question number 8. That is for 3-phase. For 3-phase, what is the total number of tons? Tons per phase. Total tons are 480 common. Tons per phase 480 by 3 is equal to 160 tons. Tons are 160. Correct? Tons per phase 160. And slots per pole per phase, SPP. Slots per pole per phase. Slots per pole per phase, SPPM. M is equal to total slots are 48. Slots per pole 4 per phase 3 is equal to how much? 4. Now gamma. Gamma is equal to P into 180 by S. P is equal to how much? 4 into 180 by 48. That is equal to 15 degrees. Gamma 15. Gamma 15. Then M into gamma how much? 60. For 3-phase, any data you take, M gamma phase spread 60 only will come. 60 only will come. Okay. Yes. Now, then calculate KD. KD. You have to calculate KD. KD is equal to sin M gamma by 2. Sin M gamma by 2 divided by M sin gamma by 2. M sin gamma by 2. So that is equal to sin M. M is how much? 4. Gamma 15. Sin M gamma by 2 divided by M is 4 into sin 15 by 2. That is equal to, calculate and tell me. KD is equal to 0.957. 0.957 KD. Okay. Now, alpha given 36 degrees. Therefore, what is KP? KP is equal to cos alpha by 2. That is cos 36 by 2. Cos 36 by 2 is equal to cos 18. Is equal to 0.951 KD. 0.951. Okay. Now, what is EPH? EPH. EPH is equal to 4.44 KP KD 5F TPH. First, you need to calculate always per phase voltage. Per phase. Endukante tons exist per phase only. Tons do not exist for line. EPH only you have to calculate every time. Line later √3 I will multiply. So it is equal to 4.44 KP 0.951 KD 0.957 flux per pole 0.025 is given na? Yes. Frequency 50 is given. Tons per phase 160. Therefore, answer is equal to how much? It will be 808 volts. 808 volts. Therefore, EPH is equal to 808 volts. That is the answer. But what is line voltage is asking line. And even EPH 808 also an option is given. Correct? You can check 808 also an option is given, A bit. But that is not answer. E line you need to calculate. So what is E line? E line is equal to √3 into EPH. √3 into EPH. Therefore, √3 into 808. How much it will be? That you will get 1400 volts. 1400 volts. Okay, that is your answer. Correct? Yes. Okay. Yeah. Hello, what is the doubt? You are raising your hand. Who is this? Hello? Fine. Any doubt? Next, this is answer. Therefore, what is your answer? Answer is 1400 volts is the answer. 1400 means that answer will be C. Answer is C. Okay. This is question number 8. Now go for question number 9. Question number 9. Question number 9. See. That is for two-phase alternator. For two-phase. For two-phase, what is the tons per phase? 480 tons. Common data it is. Number of tons are same. 480 divided by 2 is equal to 240 tons. 240 tons. Okay. 240. And what is slots per pole per phase? Slots per pole per phase. SPPM. M is equal to total slots are 48. Slots per pole 4. Per phase 2. That is equal to how much? 6 it is. M is different. M changes for two phase and 6. Then gamma is equal to P into 180 by S. P is equal to how much? 4 into 180 by 48. This is 15. Okay. M gamma how much you see? M gamma 6 into 15 is equal to 90 or not? Yes. It's a phase spread. You will get phase spread, it will be 90 only you will get. Correct? For two phase it is 90 degrees phase spread. Phase spread is 90 degrees. Yeah. Any data you take 90 only you will get. Three phase 60 only you will get. Next, then calculate KD. KD is equal to sin M gamma by 2 divided by M sin gamma by 2. That is equal to sin M. M is equal to 6, gamma 15 by 2 divided by M. M is 6, sin 15 by 2 is equal to how much? That KD. KD 0.902. 0.902. Okay. And alpha same common 36 degrees. Therefore, Kp is equal to cos 36 by 2. That is equal to 0.951. It is same. Kp same. Then what is EPH? EPH is equal to 4.44 Kp Kd by F TPH. TPH. That is equal to 4.44 Kp 0.951. Kd is equal to Kd. Kd is equal to 0.902. 5 same 0.025. F is equal to 50 tons per phase. 240. So that is equal to 1143 volts. 1143 volts. EPH is 1143. 1143. But what is E line? E line is equal to √2 into EPH, na? Yes, √2 into EPH. That is equal to √2 into 1143. 1143. That you will get 16 1617 volts. Okay, that is your answer. 1617. Answer is C. C. That is C. Answer is C. Okay. This is your answer. Root 2. Two-phase machine means root 2. And you can verify, check. Let us check this. Check. For 3-phase and 2-phase, EPH 2-phase is equal to, we know already, EPH 2-phase is equal to what? EPH 3-phase divided by 0.707. Do you remember we have got this relation 0.707? So 808 divided by 0.707. How much you will get? 1143. Then E phase 2-phase. E line is equal to root 2 into 1143. That is equal to 1617. Over answer. That's all. It's over. Correct? That is also correct. This is also correct. 1617, no? Yes. This and this. Both are same. Okay? Yes. Whatever relations we have got, they will be valid always. Valid always. Next, question number 10. Let us see. Question number 10. What is EPH5? EPH5 is equal to how much? EPH how much? Alpha is equal to 36 degrees. Therefore, you calculate KP5. KP5 is equal to cos phi alpha by 2. That is cos phi into 36 by 2. That is equal to 0. Therefore, EPH5 is equal to 0. EPH5 is 0. So answer will be, answer is C. Answer is A. Answer is A. In this question, you not necessary to do anything. Directly you can say, na? Yes. Because alpha 36 degrees. Alpha 36 means fifth is going to be eliminated. Fifth eliminate. Fifth eliminate. Fifth will eliminate. Okay. EP5 is equal to how much? It will be 0. 0. The answer is this one. Next, question number 11, let us do. Question number 11. Question number 11 is for single phase. For single phase, what is the tons per phase? 480 by 1. Single phase is 480. That is 480 tons. 480 tons. Calculate slots per pole per phase. SPPM. That is 48 slots per pole 4 per phase 1 is equal to how much? 12. Gamma P into 180 by S only. P4 into 180 by 48. It is 15. Okay. But M into gamma how much? M 12, gamma 15, that is equal to 180 degrees. The phase spread is how much? You see, phase spread always single phase. For single phase, it is 180 only you will get. For single phase, 180 only. Okay. Alpha KD, calculate KD value. KD is equal to sin m gamma by 2 divided by m sin gamma by 2. That is equal to sin m is 12, gamma 15 by 2. Sin m gamma by 2 divided by m 12 into sine 15 by 2 is equal to how much? For single phase. For single phase, KD 0.638. 0.638. Okay, 0.638. KP, anyhow, it is same, na? KP already we know. KP is equal to cos 36 by 2. It is same, 0.951. 0.951. Then EPH. EPH is equal to 4.44 KP KD 5F TPH. 5F TPH. That is equal to 4.44 KP 0.951 KD. KD is a 0.638. Flux same 0.025. Frequency 50 tons per phase is 480. That is equal to 1616 volts. 1616. Of course, that is also equal to line voltage. Phase line same. Single phase means phase line same. Phase line same. Both are same. Both are same. And even you can check. That is EPH single phase is equal to how much? EPH three phase divided by 0.5. Already we have got relation now 0.5. EPH three phase by EPH single phase 0.5. That is equal to how much? Three phase is 808 na? Three phase earlier we have calculated 808 divided by 0.5 is equal to how much? 1616 volts. 1616 volts. Okay, it would be same, right? Earlier we have got relations that I am showing. Next, 12th problem. Problem number 12. For problem number 12, for problem number 12, what it is given, if tons per phase are connected among two parallel paths, then what is the EPH? E line. For three phase only, just I want to compare. Question number 8. In question number 8. Question number 8. How it is given? All tons per phase connected in series. Question number, total 480 tons na? 180 tons are connected in series. You remember in question number 8 you see, this is a question number actually 3 phase, no? Question number 12 also for 3 phase. But here all 160 tons are connected in series. Nothing is mentioned, they are said to be connected in series, all tons. But in question number 12, the 160 tons are divided among two parallel paths. 80. They are connected in series. This is in question number 8. This is how many tons? 160 tons, 160 tons, 160 tons. 160 tons. Neutrals. And what is the phase voltage we have got? The phase voltage we have got, it is 808 volts. 808 volts. Line voltage we have got 1400 volts. Earlier, do you remember that answers? Yes, 1400 volts. Whereas in question number 12 is given, in question number 12, they are divided among two parallel paths like this. like this. They are divided among two parallel paths. Okay. These are 80 tons, 80 tons, 80, 80, 80 tons. Okay. Earlier, all 160 connected in series, but now they are divided and connected in parallel. It is only external connection, no? External connection. Instead of connecting 150, I will cut half. Instead of connecting in series, first case connected in series, next they are connected in parallel. That can be done. Okay. But what will be the voltage? Tell me. This is itself EPH, na? EPH. EPH. So therefore, what is EPH? EPH will be definitely half, as number of tons per path has reduced to half. Therefore, EPH is equal to how much? That EPH. This is EPH. EPH is equal to 404, 808 by 2. It is equal to 404 volts. 404 volts. Whereas line voltage, if you take line voltage, it will be line voltage how much? 700 volts. 1400 by 2, 700 volts. If they are divided among two parallel paths, means voltage is going to be half. It reduces half. Half. So for example, you want to do the problem. EPH is equal to actually 4.44 Kp Kd 5F tons per phase per path. It should be tons per phase per path. Okay, tons per phase per path. Kp Kd, they are not going to be changed. Winding, everything is same. Alpha, Kd, everything is same. Only electrical connection we are changing. So 4.44 Kp same 0.951 only. Kd 0.957 in the question number 8, no? Yes. Flux 0.025. Frequency 50. Tons per phase how much? 80. There 80. Okay. 80 means how much? Total tons are 160 tons per phase, no? By 2. 2 parallel paths are there. No? If 3 paths are there, by 3 I am going to do. By 3 I am going to do. This will becomes 404 volts. 404 volts. Then E line is equal to √3 into 404. That will become 700 volts. 700 volts. Okay. 700. Now last one. Last problem. It is for 2 phase. Question number 12 is for 3 phase. This is for 3 phase, no? Yes. 3 phase. But question number 13. Are you getting tons per phase per path? Only one path. First case, only one path means tons per phase by 1. It is say 168. 2 paths means divided by 2. 3 parallel paths, say voltage is going to be 808 by 3. Similarly, last question number 13 for 2 phase, no? Yes, for 2 phase. To compare in question number 9, what has given, it is also 2 phase. Also 2 phase. 2 phase, but all they will be connected in series. 2 phase. How many tons? 240. The total 480, 240. Then what was the voltage here between the phases? Phase voltage, 2 phase machine, how much phase voltage? Phase voltage is 1143. 1143 volts, phase voltage. Line voltage 1617 volts. line voltage 16-17 volts. Whereas in question number 13, they are divided like this. The turns per phase are divided among two parallel paths. Here, how many tons? 120 tons. Instead of 240, 120, 120 half. No? Yeah. Then what will happen? The phase voltage 1143 by 2 volts. 1143 by 2 volts. Line voltage is equal to 1617 by 2 volts. Okay. This will be the answer. Better? Fine. So these are problems. I am also going to do one or two more problems. Mainly where the students are in this question. Dear students, in this question, double layer winding is given. Therefore, number of coils is equal to number of slots 48. In the same question, if I give single layer winding, your answers are going to be totally different. Single layer winding is given, the number of coils is equal to half of the number of slots. So your coils are going to be only, right, half of that. Your coils are going to be only 24. Total tons how many? 24 into 10, 240 tons it will come. Your answers are going to be different. Okay, na? Yeah. So I will stop here. So almost 9:30. I will stop here, and you do practice some more problems. Anyhow, I am also going to do one or two more problems. Okay. Any doubts are there? You please ask. We will close. Any doubts? Raise your hands. Hello, Avinash, Bhanu, Bharat.
Hello, sir.
Hello.
Sir, in full pitch winding, one coil side is in north and other is in south pole.
Yes.
And sir, if we give short pitch, then for 30 degrees, both will be in north.
Yes, yes.
Sir, so in that EMF will be reduced.
Correct. Reduce only, na? KP times it will reduce.
KP times. And sir, only fundamental value or which EMF?
Of course, we have taken only fundamental we are calculated. If you want nth harmonic, KP and KP3 also can be calculated.
Okay, sir.
Alpha 30, no? Alpha 30 means you can calculate. Fundamental is cos alpha by 2, third harmonic cos 3 alpha by 2.
Oh, okay, sir.
Okay, generally
Thank
we are
you,
doing
sir.
only for fundamental. Nothing is mentioned, you have to calculate fundamental only.
Okay, sir.
Okay, right.
Hello, good evening, sir.
Hello. Good evening.
Sir, in that we are solving that the problem for the utilizing the full coil. Is there no such problems?
This problem. Yeah.
Not in that. Before that,
Before
EMF problems. Sir, in that if you give the not means if you are utilizing only half of the coil, then the formula will be changed, or we can use formula by 2.
Okay. You mean in that by utilizing all the coils? Half of the coils, yes. Half of the coils means your answer will be half only.
Total answer by 2.
Answer will going to be half.
Okay, because we are using KD is 60 by KD 90. There is terms T by 3 and T by 2. That's it.
Yeah. If you are using only half of the coils, say. Half of the coils means again how you are distributing is also a matter. Half of the coil, for example, how many you have got? For example, 4 you are getting, say 15 degrees. For example, 15 degrees slot angle. For 60 degrees, how many slots will come? 4. Okay, if all coils are used, 4. But if you use only half of the coils means now it will becomes only 2 slots only it will occupy. You cannot get 60 degrees phase spread.
Yes, sir.
Phase spread also going to be reduced. Number of turns also.
Okay, sir.
KD into tons per phase you have to calculate. And a question will be given very clearly. But half of the tons you are divided among the how many slots per pole per phase.
Yes, sir.
KD also will change. Tons will change.
Okay, sir.
Okay.
Sir, one more, sir. Normally, the delta means the slot per pole angle is there, no, sir.
Ah,
Sir, always means in practically the delta may be 15, 10 or 30 like that, no, sir.
gamma.
Yes, sorry, gamma, sir.
Ah.
Practically the 10 degrees, 15 degrees, 30 degrees, no, sir. If we use more than 30 degrees, the fractional pitch may be more than the alpha is 30 degrees, sir.
Now it can be. Not only 30, alpha can be 60 degrees also, whatever it may be. Generally, alpha will say 30. Alpha. Your doubt is gamma, na? Okay.
Yes, sir. Practically, the alpha is 30 degrees, no, sir. Sir, if we are using that 19 poles, 19 slot per poles, then if you put in large winding in the 19 slot, then we become 180 degrees. If we reduce that to 2 slots, then we become 150, no, sir. Sir, at the time the delta I see many questions, they are providing the delta is in 15, 30 or 10 in that range, sir.
Okay. Yeah.
Means practically we are using only the 10, 15, 30, sir, because if you use more than 30 means that fraction will be not come as a 30 degrees, no, sir, alpha.
I'm not getting why 30 you are discussing.
Sir, if a slot angle is 30 degrees, then we can short pitch by
Gamma
1.
30, yeah?
Gamma is 30.
Okay.
Then we can do short pitch by the 1 slot means 30 degrees.
Yes.
If you have more than gamma is 30 means 40 degrees, then practically alpha is we are providing the 30 degrees, no, sir.
Okay. And you mean 40 degrees that angle is not available. That is your doubt, huh?
Yes, sir. We are we are providing maybe mean practically alpha is 30 degrees. Then at the time gamma must be less than 30 degrees, no, sir.
Yeah.
If you use means 12 degrees, that the fraction will become. If you use the 15 degrees or 10 degrees, then we are providing correctly, no, sir.
You mean to say fractional? The corresponding slots won't be available. That's
yes, sir.
Yes. That's the reason what they will do is not exactly. It may not be exactly that angle. 30 degrees, if it is not available, next slot they will take. Practically, if you calculate, if you short pitch by 1 slot 30 degrees, say. Your doubt is if I want to go short pitched by 40 degrees means 40 degrees corresponding slot is not available. That's the reason.
Yes.
And that's the reason you have to keep either 30 degrees or 60 degrees. That's all. The next slot or else next slot. 40 degrees is not possible there.
Okay.
Practically, while you are designing, all the things will be taken care. First, you will calculate everything. Then only you will design the slots. Then only you will design the machine.
Okay, sir. Sir, one more, sir. We are providing the phase. One more is the 3-phase in 120 degrees of phase spread. But you are saying that for eliminating of the turbulent harmonics, we are using the 120 degrees phase shift.
Yes.
Is it correct, sir?
120 degrees phase spread. Yes.
Sir, but in stator, maybe the armature winding is providing in the star connection means it's line. It's automatically reducing limiting the third harmonic, no, sir. Turbulent harmonics.
Yes, exactly.
Then what is necessary for 120 degrees phase spread?
No, no, if you want to take across the phases, I want to take only phase voltage. I don't want to see any triplet harmonics. Line anyhow, 60 degrees phase spread eliminate. Good, correct, you are right.
But 120 degrees, what is necessary in the star, sir?
No, that's what I am saying. 120 degrees very rare. If some applications require single phase operation, phase to neutral, no? Phase to neutral, I want to take. I don't want to see even in the phases. That is only theoretical approach.
Okay, sir. Can we say that 120 degree phase spread used in practical in delta connection of the star winding?
Both.
Because in delta connection, the circulating current will become the tripling harmonic is not eliminated. At
Yes,
that time, 120 degree phase shift will be used.
In 120, if you use, there will be no circulating currents.
Means it's a practical application of 120 phase shift in delta connection of star winding.
Yeah, delta connection of three-phase delta connection, if you use, there will be no circulating current. But what is the advantage by connecting delta? First of all, alternator is not preferred connection of delta. Star connection only preferred.
Yes, sir. In some rare case.
Yeah. Some rare cases, if you connect in delta connection, I don't want to see triplet harmonics, then only.
Okay.
Yes, you are correct.
That's all, sir. Thank you so much, sir.
Right. Okay.
Hello, sir.
Hello. Yeah, tell me.
Sir, in yesterday's class, you are told about coil angle and pole angles. Sir, how we practically measure actually coil angle or pole angle in machines?
Pole angle, huh?
Yes, sir. Pole angle and coil angle also, sir.
See, pole angle is nothing but angle for each pole. See, I have told this is your if I am taking one salient pole, okay, one salient pole. This is excited with the DC. For example, say it is north pole. How the flux distribution of this? You take flux distribution. Here, MMF constant, flux is equal to MMF by reluctance. Okay. Now, here air gap is more, flux is less. Air gap decreasing, flux increases. Air gap decreasing. When air gap decreases, flux increases, na? Yes. Decreases, flux increases. Flux increases. Flux is more here. Similarly, air gap increases, flux decreases. Air gap increases, flux decreases. Air gap increases, flux decreases. Air gap increases, decreases. Like that. So, what is the flux distribution under North Pole? B wave. Okay. B wave, that is due to North Pole. It will also generate EMF of same thing. EMF waveform. Right. This is said to be how much angle now? This angle is equal to 180 degrees now?
Yes, sir. 180 degrees.
One half cycle is nothing but 180 degrees. Then it will also generate. For example, if you keep one conductor, when one pole is going, it will generate one half cycle. It will create angle of 180 degrees.
Okay.
That is only half cycle. Based on the half cycle now, AC means one half cycle you are getting each pole. The flux distribution. North pole it is B wave positive. South pole it is going to be negative, I will take.
Yes, sir.
On this you may be feeling, see, mechanical angle will be different. If you use a 2-pole electrical mechanical same. 4 poles means 90 degrees becomes 180 there. For 4-pole machine, 4 poles are there. Na? You take only one conductor. Within one rotation, how many half cycles will generate? North pole going positive half cycle. Next south pole is going negative half cycle. Next north pole. But within one rotation, all 4 poles will passes through this conductor. They will generate 4 half cycles. Rotation is 360. Rotor has been rotated 360. It has generated 4 half cycles. For half cycle means each half cycle 180. For 180 is 720. That is electrical angle. Electrical angle you have to say with respect to waveform. Waveform angle. Okay.
Sir, coil angle, sir.
Coil angle means coil pitch. See, coil angle means how we are keeping. This is my it's called coil pitch. For example, I am taking a 4-pole machine, say 4-pole machine. This is one. North pole, south pole, north pole, south pole, north, south, north, south, south. It is having so many slots. 1, 2, 3, 4, 5, 6, 7, like this. We are keeping, say, if I am keeping here one coil here, other coil here, under this pole. This is one coil. What is the coil span? Tell me. What is the angle? This angle? What is this angle? 180 degrees. This angle is 180 degrees from here to here. Yes or no? Why? Because center of the south pole, center of the north pole. What is the angle? Electrical is 90. Mechanical is 90, but electrical is 180. This is said to be coil pitch. Coil pitch from here to here, you have to calculate. Coil pitch. Coil span. This is itself coil span. Coil pitch is equal to how much here? It is 180 degrees. Coil pitch is 180 degrees. If you keep less than this, for example, if you keep the same coil less than that, then it is going to be short pitched coil. Instead of keeping here, if you keep here, that is going to be short pitched coil. Okay, this is itself short pitched coil.
Yes.
Short pitch means if I have taken this like dashed line, short pitched coil. What is that coil? It is less than 180, na?
Yes, sir.
Coil span means this one side of the coil to other side of the coil we are keeping. 1 dash, say for example, this coil one side, other side, how you are keeping. There's a coil span. And the angle, how it is getting on the machine, you are keeping one side of the slot, other side of the slot. What is the angle between this side and this? That is itself coil span.
Okay, sir.
Center to center, it is 180 degrees. That is a full pitched coil. If you keep less than that, angle is going to be less. Of course, mechanical angle you are feeling always, but you need to convert that into every time electrical angle.
Yes,
90 mechanical, but electrical is 180. Peak to peak. No? For example, you are at the center of the pole, south pole, center of the north pole. What is this angle from here to here? Is it 180 or not? Yes. Like that. On the diagram, how we are showing is like this. Okay.
Yes, sir. Got it.
Right.
Thank you, sir.
Okay. Yeah. Anyone? Hello. Hello.
So can you show in the previous lesson, question 9?
This one, huh?
Question 9 solution. Sir, here, not this question, I guess.
Huh?
10th one, question 10.
Okay.
So here, flux also changes now, sir, with money.
Machine same data given. Yeah, why it will change? Same machine only, same turns only. Already 3 phase is there. I will convert that into 2 phase. Flux same poles only I am using. Same current, everything. Machine is same. Total number of turns are same. Only winding is, instead of dividing among 3 phases, I will convert everything into single phase.
Okay.
single phase. So flux per pole same. Kp also same. It can be alpha is any short pitch coil. 30 degree short pitch you can use anywhere, but only m will changes. That's the reason m gamma kd is going to be changes. Kp will be same.
Not
Flux
this
per
one,
pole
sir.
same,
I
frequency also same. Common data it is.
I asked about the 10th one, sir, for harmonics.
Okay. Fifth harmonic alpha 36 is given. Na?
Yeah, the reason Kp5 is becoming 0, that's why we are getting
Yes.
EMF is 0.
Exactly.
But the flux per pole will change also with harmonics.
Whatever, exactly. You are right.
Do
But
we have
those
any-
flux, whatever may be the flux, first of all, Kp5 means EPH5 0 only, na?
Yeah, that will be 0, sir. I'm asking of that flux per pole. Like, do we have any relation between fundamental and the harmonic flux?
Yes. And not just flux, there is a relation is going to be like this. We are also going to see. Phi is equal to 2dl by P into Bmax. Phi is then a fifth harmonic flux 2dl by phi P poles. This is P into Bn maximum, nth harmonic maximum flux density.
And therefore,
Yeah. Of course, you can also bring that phi by phi is equal to, but it should be in terms of Bmax.
yes.
Maximum flux density will be given. Then only you can say. But fifth harmonic flux is equal to not 1 by 5. We cannot say. It depends on the dimensions also.
Okay.
These relations we will get.
Okay.
These relations also we are going to do one problem based on this. So EMF equation only, one problem only, but all varieties we need to cover. Okay.
And if they ask about KVA rating and EMF induced in case of two-phase and single phase, we can use this direct results, no, sir.
Yes. Directly. At that time, the questions are triplet questions. If like that, 3 questions are given, I can do directly. But every question is given individually, say.
Okay. Then we have to do all these things.
Yes. At the same time, I am checking so that whatever we have got the relations, they will be valid. Okay. Fine. So I am closing my session. Good
Hello,
night.
sir.
Yeah, tell me.
Sir, one last question.
Uh,
Sir, there is one question in that. A alternator for full pitch stator winding, the generator voltage in both coil sides are, there are options, sir. Exactly 180 degrees out of phase. Another one is exactly in phase. Which one is correct, sir? Means
Repeat the
we are
question. Repeat the question.
in case of alternator for a full pitch stator winding, the generated voltage in both coil sides are
Phase opposition. E1 and E7 you take phase opposition.
yesterday we did know, sir. E1 and E7 is
Yes. Phase opposition.
but in answer is the exactly in phase, sir.
No.
He's given an
Across the coil, net voltage will be additive polarities, aiding polarities. Potential difference we need to take, na?
Yes, sir.
That maybe answer is wrong. Options may be given wrong. It will be in phase opposition.
But explanation also there, sir, for that.
What is the expression?
In an not explanation, sir.
What is the explanation? Both are aiding polarity.
In an alternator for a full pitch stator winding, the generated voltage in both coils should be exactly in phase. Otherwise, the net generated EMF will be 0.
See, this is coil 1. That analysis is different. E1 and this. What is the potential difference? If 2 phasors are in say coil is there, this is the coil. Where you can measure the voltage with a voltmeter across these ends, na?
Yes, sir.
This is a potential difference. Okay. Potential difference across this. Like if 2 phasors are in same phase, what is the potential difference? 0.
Yes, sir.
That will be. It is not like the aiding polarity are correct. The induced EMF on 2 sides of the coils are said to be aiding polarity. Aiding polarity. That is correct. But here it will be in phase opposition. E1 I have taken
Yes, sir. E7.
E7. There is a space difference is there. Space difference is there, na? R phase to Y phase 120. You are keeping phase difference how much? R phase to Y phase 120.
120 degree.
But in coil also, one side of the coil in first start, other side of the coil is 180 degrees. Then what is the phase difference between E1 and E7?
120.
180. If you pitch at 180.
Yes, sir. Sir, the correct option is exactly 180 degrees out of phase.
Yes. That is very well known question. So answer may be given some different way, not like that. Aiding polarity correct.
Okay, sir.
Hmm.
Thank you so much, sir.
Okay.